and welcome from STEAMSPACE Education Outreach. We are thrilled to be with you today for our very first completely virtual Cities in Space, as well as our third international competition and conference. It has been an unusually challenging year for all of us globally. This can be particularly said in the realms of education. In a normal year at our Cities in Space events, we would all be coming together in person. Each year, since 2015, STEAMSPACE events have hosted over 500 students and teachers, as well as industry professionals, scientists, artists, and space leaders at the Cities in Space conferences. When thinking about the pandemic this year, we thought, well, if we were living in an off-world community, our event would very much look like this: a global interaction via video and conferencing and sharing our experiences despite the distance. So here we are, and we thought this is a moment we can do this together. Though we cannot share a meal together in person, we can still celebrate and discover our future together. Because it is you, students, right here, right now, who will create our future in space. It is you who will go the distance and build new worlds. It is you we depend on for a bright and inspiring story of where the human race will go next. And that next is just around the corner. And when you are living in your thriving community on the moon or on Mars or in distant free space, you will all need each other. Because it won't just be about the engineers and the chemists and the architects, though they will be highly essential. It will also be about the agriculturalists who grow the food, the doctors who heal. It will be about the artists who create design and create aesthetic harmony for your community. It will be about the musicians who inspire that community. It will be about the counselors who create healthy mental transitions for new arrivals and the historians that continue the story of humankind. Indeed, all will be needed. Today, we will hear from some brilliant and inspiring minds. From the realms of rocket science and biology, to commercial space, to the Moon Village Initiative, to discussions on our story of where we have been and where we are going, to film and the arts, to what companies are doing to include civilians in space. For those of you who have registered and are competing today, we have your breakout rooms ready at the scheduled time, so make sure to have some intimate questions ready for your designated speakers in your breakout rooms. We are also looking forward to seeing you at our celebratory star party tonight, hosted by our amazing partners in astronomy and education, SLU. Thank you, SLU. I'd like to give a special thanks to our supporters today and our collaborators for Cities in Space. A huge shout out of thanks to the Musk Foundation for your support of our future leaders. Special thanks to Firefly Aerospace for your continued support and engagement through the years with our youth since 2016. Ball Aerospace for your engagement, and Janet's Planet, inspiring young minds towards STEM and STEAM in space globally. Thank you. Special thanks to our streaming host, E360 TV. E360 is revolutionizing streaming conferences, shows, and events, and it has never been clearer how much that service is needed than this past year. We are grateful for you, E360. Thank you to our amazing and dedicated judges, many of whom have been with us since our first days in 2015. We could not do it without you. This year has been such an exciting year watching our Cities in Space teams videos come in from all over the world. Our amazing advisory board who has supported us through the years, and a personal shout out from me to our STEAMSPACE team for making this grand leap happen despite the challenges of 2020. Our Director of Operations, Amos Bahana, our IT Administrator, Chris Larson, our videographer, Weiss Cutler, our photographer, Scott Jarrett, and our STEAMSPACE Academy support, Natalie Mendez. Thank you from the bottom of my stellar heart. And with that, let the day of discovering your future begin. For questions about this schedule, please visit our site at steam-space.org and go to the Cities in Space 2021 page. Teams, for breakout rooms, please have your invitation link available so that you can hop on at the scheduled times. And now, on behalf of our Board of Advisors, I would like to welcome Sophie Williams. Sophie is on a mission to assist young entrepreneurs build careers and businesses that are sustainable and profitable. Sophie is a member of the STEAMSPACE Education Advisory Board and a sponsor for Sky's the Limit and the Network for Teaching Entrepreneurship. Educated in advertising and marketing, her background encompasses corporate communications, event planning, project management, and strategic planning for business development. Sophie is an executive business partner at Accenture and a University of Texas at Austin alum. Please welcome Sophie Williams.
Hello and welcome. On behalf of STEAMSPACE Education Outreach and the entire Board of Advisors, we are thrilled to have you here today. Part of our STEAMSPACE mission is to reach as many youth as possible. We believe in breaking down the barriers of economics, gender, race, ideology, geography, and want all students to have the great opportunity to not only find each other, but also see those professionals who have gone before them and what opportunity lies ahead for college, career, and beyond. It's going to be a fantastic day. Again, we are thrilled to have you here. Upwards and thank you.
Thank you, Sophie, for that, and thank you for being here today. Our first speaker of the day is near and dear to our hearts and a big inspiration to all of us in our local community. The team at Firefly Aerospace has supported Cities in Space for many years with amazing employee engagement, bringing judges to our Cities in Space, sponsorship, and supporting our students. Chief Executive Officer at Firefly Aerospace, Tom Markusic, has been in the aerospace industry for over 20 years. Firefly Aerospace is a rocket company and is headquartered in our very own Austin, Texas. They are committed to providing economical and convenient access to space for payloads through design, manufacture, and operations of reliable launch vehicles. Tom is here to discuss the future of space launch and exploration and where we will be going, including talking about Mars. Special thanks today for Firefly and their amazing work they've done through the years with our students and their sponsorship. Please give a big welcome to Tom Markusic.
Going to space is probably about the hardest thing you can do. If you can achieve it, you've done what is seemingly impossible. We're not just buying other people's stuff and putting it together. We have to engineer all the pieces, parts, put them into assemblies, and test them for the first time. We have to solve problems that none of us have solved before. Firefly's goal is to build a rocket that can get small satellites to space.
The challenges and problems make you dig deep and think like you've never thought before.
I made the modifications for the thrust chamber to interface with the new...
You get to imagine things and try and make them a reality.
This place is fast-paced. You always have your next goal. We're always hustling.
Space has always been intriguing. But what's unique about this time now is that there's big business to be had in space. Its estimates are on the order of $3.2 trillion in revenue by 2045, dwarfing any other business.
Final configuration. Operator, please check NPTO1.
Firefly is in a stronger position than it's ever been. We have an investor that's dedicated to pay the entire bill to get us to space. We do need some more people to help us get to the next level, but everything is in great shape right now at Firefly. People are the most important thing at Firefly. You know, I'm the CEO, but I'm out in the field working with the team on building the rocket engines. We're just a bunch of guys and gals trying to do something amazing. You won't find hierarchy here or a lot of roadblocks or bureaucracy.
The culture's very sort of family-like.
Test execution. RE. Verify blue lines are met. Operator, stand by manual abort. Start camera recording and start auto sequence and provide a countdown.
Starting auto sequence. 5, 4, 3, 2, 1, 0.
Firefly is great because you really feel like that you're putting your personal touch on this vehicle and on this system.
Just to be a part of the beginning of it all is an amazing feeling.
Working here, you get an opportunity to work on something that's going to be very impactful, literally extending humanity's reach into the universe. And that's something, in addition to being economically secure, you can look back in your old age and be proud of and talk to your grandkids about. Hello, everyone. I'm Tom Markusik, the CEO and founder of a company called Firefly Aerospace. Today, I'm going to talk to you about some visions for how we could explore space. You know, I understand I'm talking to a younger crowd of folks today. My interest in space really started around 5th grade. My parents got me an Estes model rocket for Christmas, and I went out in the snowy fields of Ohio and I launched it, and that really kind of captured my imagination about, you know, space and space exploration. And ultimately, that seed grew into more and more interest, where I, after high school, went and studied how to build machines to go to space, and eventually worked for NASA, the Air Force. I worked for Elon Musk at a company called SpaceX that you may be familiar with. And eventually I decided to start my own rocket company that's called Firefly. And we're headquartered in Austin, Texas. And we're at a really exciting time where, having worked several years really hard, we've actually built our own spacecraft and rockets. And I'm talking to you today from our Vandenberg Air Force Base launch facility in California, where in just a few weeks, we're going to launch our first rocket into space. So very exciting time for our company. And it's just really exciting to me to see the excitement that I had as a middle schooler now, many years later, materializing into the ability to go and build my own company that can go and explore space. So today, I'm not going to talk to you so much about my company, but more just about some ideas about how we might go out and explore space. There's something inherent in human nature that we just love to explore. Hundreds of years ago, we explored our world and the New World was discovered. And now we have the ability to build machines that can take us from Earth and go out and explore entirely new worlds, which is equally exciting, and it's a great adventure, and there are going to be great rewards out there when we do that. So in particular, today I wanted to talk to you about some ideas I had for colonizing Mars. Now, what's different about this, what I'm going to talk to you about, is I propose a very incremental approach in doing that. And by incremental, I mean we do it in little steps instead of one giant leap to go there. Maybe it makes more sense to do it in small steps. So the first part that I'm going to propose is this part 1, which I call a material supply fleet. And what that means is initially if we're going to colonize Mars, it may make sense to get the highways done first, to get the supply chain done first, so that we can easily move supplies back and forth between Earth and Mars to make that later human exploration easier. So on this slide is a picture of a galaxy, and this just emphasizes very big picture and why space may be interesting on many, many levels. You can think of space and interest in space just in the origins of where did it all come from. It's almost really a religious or a philosophical question, right? You know, we think we know about this thing called the Big Bang, but you know, what happened before the Big Bang? And it really can go beyond even our ability to comprehend as humans. Another thing you could look at space, if you're interested, is just how space works. It is here. Forget about how it got here. We don't know, but we know it is here. So how do stars form, and how do planets form around stars, and how does life evolve on planets and things like that? Another thing that's interesting about space is how can we get out there and explore it? And that's really what my passion is. And that's what I've dedicated my career toward, is building machines that allow us to go out and see these places firsthand and to walk on these new worlds. So, you know, one thing that I want to tell you from the beginning is our predecessors really were working hard in the 1960s, and they figured a lot of this out. They figured out how we could go out into space and go places. I'm sure many of you seen like the movie Apollo 13, and you understand how in the 1960s we were able to build machines to go from the Earth to the moon. But those folks that did that, really, they were incredible. They were not only ready to go to the moon, but they were able to go beyond to Mars, and they actually developed the technology to do that. And that's what's shown here in some of these images. They developed advanced rocket engines that used nuclear power and really figured out not only how to go to the moon, but how to go beyond to Mars. But unfortunately, something happened, and that all kind of came to a grinding halt after the 60s. And you know, I'm sure some of you are familiar with the Eagles song, Hotel California. Welcome to the Hotel California. You know, it's way before your time, but maybe you've heard it in the car or whatever. And one of the lyrics in there that I reflect on that's applicable here is, we haven't had that spirit here since 1969. And it's really kind of true in space exploration. Our aspirations and the work that we've done has been kind of boring compared to what they were doing in the 60s. And there are a lot of reasons that occurred, but instead of talking about that all day, maybe we can think of the spirit of what they're doing and do it in a different way. And that's really what I wanted to talk to you today about. This, what I'm proposing is this incremental approach to exploring the universe. Now, again, by incremental, I mean taking the problem and dividing it into smaller pieces. So let's just reflect on kind of size and time and how they apply to us as people. Now, for the distance from the Earth to the moon is about 200,000 miles. So I'm sitting here in California. I flew from Austin. That's about 2,000 miles. So about 100 times further than that distance between Austin and California is the distance to the moon, about 200,000 miles. Now, to Mars, it's about 100 million miles, much, much, much further. And then if you look at the nearest star, Alpha Centauri, it's actually 25 trillion miles away, very, very far away. When you look at how long it took us to figure out how to get to the various places, it looks like this. Now, when those brave and hardworking folks from the 60s decided to go to the moon, it only took them about 10 years. But Mars, as I said, we haven't gone there, and it's really, you know, we're 50 years from the 1970s, and it's really going to take us at least another 10 years to figure out how to get there. So, you know, overall, you know, that's over 60 years between making that next jump to get to that 100 million mile mark. Now, if you look at something like another star, 25 trillion miles away, using that same kind of reasoning, you know, it could take us 15 million years before we figure out how to go to another star. Now, I don't know about you, but I don't want to wait 15 million years. And indeed, in the human lifetime, we can't even contemplate such things. So a question that I've thought about is, instead of waiting so long, how can we do interesting things in smaller steps that are nonetheless very exciting, but aren't, the whole enchilada, that we're not waiting the whole 60 years to do it. And that's the subject of what this conversation is today. So let me be a little more specific about what I'm talking about. It's always interesting and beneficial to think about doing two things at once. For example, if you think about some of the problems we have, how could we solve those problems and also get to do other cool things at the same time? And what occurred to me is that the space around Earth is becoming very, very crowded. There are going to be 57,000 satellites around Earth by 2029. Now, that very crowded space creates problems. Things can start running into each other, and we could just have a big kind of space pollution problem. So when I was thinking about that, I was thinking about how could we tie this into the bigger dream of going to other planets. Now, this is an image of Mars here, and around Mars, there's a small moon called Phobos, it's shown here. And I started to think about, instead of going directly to Mars, what if we could go to Phobos, which has very little gravity, it's very simple to land on it, and maybe we could do some very interesting things on Phobos before we did the full-scale colonization of Mars. And what if we could somehow tie this need to cleaning up Earth orbit to being a stepping stone to going to Mars? And the particular idea that I was interested in is, what if we could take some of these things that are around Earth and we could deliver them to Phobos, and those things could be used to build the colony that we would ultimately have on Mars. So this slide is very complicated, and it shows all the things we need to do over the next 60 years to get to Mars. So I won't bore you with all that. And as I said today, I wanted to talk about an incremental approach. And that's what I've highlighted in this yellow box here, is like, hey, why don't we just go and do this like right now? And this can serve as a critical link between Earth and Mars ultimately, but we don't have to wait. We can go and do it today. So the mission that I'm proposing that we do today, as I described in those earlier slides, is to use space cargo tugs to salvage the old and used satellites that are around Earth that have become kind of a nuisance, and transfer them to Phobos as an equipment supply depot for future manned missions to Mars. So if you think about, if we're going somewhere else in the solar system, we're going to need stuff, right? We're going to need supplies. We're going to need raw materials. We could mine those from asteroids, but satellites themselves are full of super valuable stuff. There's no asteroid that you could mine that has electronic systems already built and ready to go. There's no asteroid that you could mine that has solar panels that you could use for power. So the very intriguing idea that I've thought of is to use space tugs to go into the orbit of Earth, take the old and really nuisance satellites that are just kind of creating junk and a nuisance, and drag them to Phobos and drop them there, and basically create a huge junkyard that could be used in the future by astronauts to create the supplies that they need. So this is just another slide that shows that these things exist in space. This satellite, for example, this satellite probably cost $1 billion to put in space, but after it reaches the end of its lifetime, it's useless and it's actually a nuisance. So if we could actually go and grab that $1 billion satellite and drag it to Phobos, astronauts in the future could land and they could actually take this satellite apart and build new things from it. And that really creates intriguing possibilities for what we could do here on Earth too with students, for example. We could have design competitions where if you had access to the information about what all these satellites are made out of, how could you take it apart and kind of make a new Lego kit to make something new and useful, like a microwave oven or a air purification system, or you can just imagine 1,000 things like that. Now, doing what I've said, you may sound a little futuristic, but it can actually be accomplished very soon in the near term. We have all the technologies to go and do something like that. Now, we don't have all the technologies to send humans to Mars, but we do have all the technologies we need to go and harvest these satellites and just start dumping them on Phobos so that when the humans do come, they will have a big junkyard full of things that they can use to help really jumpstart and build that colony on Mars without having to bring all this stuff when they fly there in the first place. So lastly, and this may be a little bit too much technical detail for you, again, talking about the technology associated with doing this, here's some examples of the things that we would use. There's solar electric propulsion that can be used for that space tug to facilitate grabbing the spent satellites and flying them to the remote destination of Phobos. These are things that I've worked on in the past. The solar power just makes them very efficient. Although it will take a long time to get from Earth to Mars, you could haul a lot of payload in the very near term by doing that. Now, the satellites and things that we would be harvesting have very common system designs that are well understood and could be used to put together the type of equipment that we would want to use on a future robotic colony. So that's really the conclusion. I just wanted to give you a short snippet, a short idea of thinking about an example of things we could do to get out and explore our solar system right away in this incremental approach that I'm proposing. There are 100 different or 1,000 or millions or unlimited things you can think about when it comes to going to space. But I hope, nevertheless, that this one idea has been interesting to you and will provoke some thought in you. Because again, reflecting back on our Eagles Hotel California, the other lyric that I really like, that, and still those voices are calling from far away. So even though we haven't had that spirit here since 1969, people like me, and I hope you, can hear those voices calling from far away, and that you'll ultimately get to do cool things in space like I've been blessed with the opportunity to do here at Firefly. Thank you.
Thank you, Tom, for inspiring us and showing our teams where they can go for such an exciting, amazing career and future in the golden age of space and exploration. Our next speaker last spoke with us in 2017. Then she was just starting our business. Morgan Irons is the founder and chief science officer at Deep Space Ecology. If you ever wanted to see a woman driven to support food and ecological systems in off-world communities, look to Morgan. The work she is doing will support our knowledge not only off-world, but also here at home on Earth. Morgan is an ecologist and an environmental scientist. Her research is focused on understanding and applying ecological theories and principles to develop and manage quasi-closed agroecological systems for use in extreme and changing Earth and space environments. Morgan and the DSE science team seek to understand how biomechanical cycles and feedbacks may be developed in sterilized, degraded soil or regolith conditions through conducting foundational research and field applications. Morgan Irons attended Duke University and earned her Bachelor of Science degree in Environmental Science and Biology and a minor in Chemistry. Please welcome Morgan Irons.
Hello, everyone. My name is Morgan Irons, and I am the founder and chief science officer of Deep Space Ecology. I am also a PhD candidate in the field of soil and crop sciences at Cornell University. But besides those titles, what do I actually do? So I am a soil scientist and an astroecologist. So I pretty much work with soil, as well as work with plants and microorganisms and see how they interact with the space environment. But I didn't always want to be a soil scientist and astroecologist. I didn't even know what those were when I was younger. So I want to take you guys back to my past, where all I knew at that time when I was a young kid was how beautiful and awesome space was. And I remember sitting outside camping with my family and looking up at the stars and just having this question in my mind where I was thinking, are there plants on other planets? Is there life out in our solar system, out in the universe? If we were to visit another planet, would we see forests like we see here on Earth, or would they look different? Would they function differently? And I had all these questions about not only how the environment works on Earth, but what would we find on the moon, what we would find on Mars, what we would find just out in our solar system. And so throughout my life, I have been very passionate about space exploration, as well as the environment that we have here on Earth. Some of my favorite classes were like environmental science and biology. I was very much interested in understanding how ecological systems function, and then just being able to go out into space and explore and see what's out there. But I didn't really see a career path with that. I didn't really understand how I could combine environmental science and space exploration together. And so I was going through elementary school, going through middle school, not really thinking about college at that point, but kind of wondering how I could combine environmental science and space exploration together, and not really seeing a connection there, when something happened. So I had a medical situation that came up where I was in middle school. I was a lot of your guys' ages, and I lost the ability to walk. I could not use my left leg. I couldn't use it for 2 years, and so for one of those years, I was in a wheelchair. And through that experience, I determined a path for myself. I didn't really see a path for space exploration and environmental science at that age, but I saw a path for medicine. I saw that I could go into orthopedic surgery because of all of the surgeries that I went through. I had exposure and was able to talk with these orthopedic surgeons, and I saw a career path for that. And I was building a passion for medicine and being able to help people who are going through medical challenges. And so when I was eventually looking at colleges, I ended up going to Duke University to pursue medicine, to eventually go to medical school. But while I was there, I didn't only focus on academics. I got involved in a bunch of different things, going hiking with friends, volunteering in my community, working different jobs in science labs, working with different technology. Pretty much what I was doing was I was exploring. I was pursuing my interests. I was seeing what was out there. And I was also meeting a bunch of very cool, very interesting people that had different life experiences and different perspectives, and allowed me to be exposed to different topics and different people, which allowed me to broaden my worldview and see potential paths out there that I had never considered before. And by exploring, by exposing myself to different topics and to different people, my mind kept going back to those initial memories, these initial passions that I've had since I was your guys' age, where I've always loved the environment. I've always loved space exploration. Even in college, my friends would tell me, Morgan, why are you not pursuing environmental science? And this led to some turmoil for me, where I got confused and I didn't know what I was going to do. And this was around my second year at Duke. And I didn't know what to do. I didn't know what path to take. Should I try for space exploration and environmental science, even though I didn't know how to combine those things together, or should I continue on in medicine? And this is where my dad stepped in. We've probably all had a parent step in to help advise us on things before. And for me, my dad was the one who stepped in. And he asked me two questions. He asked me, what is your passion? What would you be happy doing every day? No matter the money you earn, no matter the prestige, what would make you happy? What would bring a smile to your face? And my core being was like environmental science and space exploration. I've always loved these. My friends can see my passion for this, but I don't know how to combine those two things together. And that's when my dad said, put in the work. Figure out how to combine those two things together. Actually explore. Go out there and figure out what people are doing in research, what careers are out there that may combine these two things together. And like Dr. Carl Sagan said, somewhere something incredible is waiting to be known. We don't know what that something is. We don't know where it is, but it's out there. And for us to be able to discover it, we need to explore. And that's what my dad was telling me to do. He was telling me to explore. And so I did. And eventually I found this paper on this research that was done by Soviet Union Russian scientists who were doing these closed ecological system experiments for space habitation in the 60s and then the 70s. And that was it. That was the bridge. I could look at closed ecological systems for space exploration because it combined my passions for environmental science and my passion for space exploration. So there was a path out there, but it took me exploring and really allowing myself to look that allowed me to find it. And so nobody at Duke University was performing closed ecological system research. Nobody was performing space research. And so there really wasn't an opportunity there for me to just join a lab and pursue research that way. So in this case, an opportunity wasn't available. So I had to create my own opportunity. And to do this, I contacted these different professors who may have interest in exploring their field with a space twist to it. So these were the three professors that ended up saying yes to mentor me, who allowed me to perform closed ecological system research for space habitation and provided their perspectives from an ecology perspective, a soil science perspective, a biology perspective, and allowed me to really explore. And I was able to actually design and perform my own large-scale Mars agriculture experiment, where I was using Mars regolith simulant to grow different plants in it and to understand how you can take such a degraded geological substrate, a degraded soil, and revitalize it to support a biodiversity of plants and microorganisms. And so I was able to perform this experiment in the Duke research greenhouses. I was able to work in the lab to analyze my results. And I was able to create a thesis off of this, where my research looked at the development of ecological and environmental mechanisms in sterilized Mars regolith simulant to drive primary succession and the establishment of a closed ecological system on Mars. Very long title. That tends to be something that scientists do. You always have to have that long title. But I was able to perform this experiment, and pursue my passions and connect my passions for environmental science and space exploration. And I had a wonderful time doing it. And what I saw was I was able to take material like this geological substrate that we would find on Mars, on the moon, and create something that looks like soil. That soil that you see right there that looks rich and fertile, that was originally like what we'd find on Mars and on the moon. But I was able to revitalize it for it to be able to support microorganisms and support plants. And this made me realize how important soil science is. But we'll get back to that in a moment. And so from my research, I actually founded my company, Deep Space Ecology, because at that time, when I was doing this research, nobody was really talking about space agriculture. This was pre The Martian. So before we saw potatoes growing in Mars regolith on the big screen. I founded the company Deep Space Ecology to work on these questions of food security and developing agricultural systems on Earth, in space, and as we explore out into our solar system and eventually the universe. And by changing my path from going from pursuing medicine to pursuing my passions for environmental science and space exploration, I've had so many opportunities to talk with people, go to conferences, go to NASA, talk with people at NASA. It's been a wild ride. And I ended up graduating from Duke University with Bachelor of Science degrees in environmental science and biology with a chemistry minor. And what I learned throughout that experience was, do not be afraid of change. I was afraid to change my path from medicine to my passions for environmental science and biology and space exploration because I didn't know what was going to happen. There was so much uncertainty with it. But by facing the risk of that uncertainty and having courage to change my path, I have gained so much fulfillment and so much joy from the work that I'm doing and being able to pursue the passions that I've had since I was young. And now on this path, I'm now at Cornell University, where, like I said, I'm a PhD candidate in the field of soil and crop sciences. And my work allows me to work with microorganisms like bacteria and fungi and look at their dynamics in soil systems, not only here on Earth, but also in space. So I currently have an experiment on the International Space Station where we're looking at microbial soil biology, chemistry, geology dynamics in the microgravity environment. And all of this was because I was willing to take that risk to change my path and pursue my passions. And it's been a wild ride. This experiment that I have on the International Space Station took 3 years to plan. So sometimes the goals that you set take time, but when they happen, it's so fulfilling, and it's an amazing feeling to finally reach a point where you're like, I put in the work, I put in the time, and now I'm having success and enjoying myself. And here at Cornell University, I have 3 mentors who are on my PhD committee, who are helping me pursue my science, helping me by advising me with their knowledge, with their experiences in soil science, soil chemistry, microbiology. And so what I've learned throughout this entire experience is I need to surround myself with people who will support my dreams. And that's something that you should do as well. Surround yourself with people who care about you, who care where you're going in life, who will help you and advise you, who won't tear you down, who won't tell you that because of the way you look, you can't pursue something. Those are the people you need to ignore. The people who tell you you can't pursue something because of the way you look, because of your age, because of your educational level, don't listen to them, because those opinions don't matter. The opinions that do matter are the people who truly care about you. So surround yourself with people who support your dreams. And no one can define your limits except yourself. So tell yourself that you can do something, that you're willing to try something, that you'll work through it until you get it right, because nobody can stop you except yourself. And with that regard, don't see your failures as a negative. See failure as an opportunity to begin again with more knowledge than you had before. Because when something goes wrong and something doesn't go right, like with an experiment, you see what happened, you gain the knowledge of what went wrong, and then you try that experiment again, and the next time it can be successful because now you have that knowledge from that first failure that allows you to learn and continue and to have future success. And so find mentors and advisors that can help you work through your academics, your career, who can help advise you. Like I had advisors when I was a college student at Duke, and now advisors as a PhD candidate at Cornell. And throughout this, listen and learn, because these people that you surround yourself, these advisors, these mentors that you have, will teach you a lot. And they will allow you to actually have success and be able to pursue your dreams and your career. So set your goals and decide on a path. Do not be afraid of change, especially if that path you originally set does change. So do not be afraid to change that path and go on to a different future than what you may have seen, especially if that new future gives you fulfillment and makes you happy. I'm an example of someone who changed their path and is now having a wonderful time on this new path. And pursue your passion and work hard to achieve your dreams. Always work hard, because it is the effort that you put in that will really propel you forward with your work. And your passion can become your career. As long as you put in the work, you find the mentors to help you, you take the classes that you need to take, and you gain the skills you need to gain, you can pursue a career that can give you fulfillment in your life and can bring that smile to your face every day that will make you happy every day. And be kind to yourself ultimately. Give yourself a break, especially if there are failures that happen. There are things and people that say negative things to you. Be kind to yourself. Understand that it's all a work in process, that you're learning and growing, and that everything takes time, and being kind to yourself will ultimately allow you to continue to move forward and allow you to be your own biggest advocate so that you can pursue your dreams that you may have had since you were a child, when you were younger, or what the dreams that you have now as you sit wherever you're sitting watching this conference, as well as the dreams that you'll have in the future. As you go off to college or go into a trade, just remember to pursue your passions and be honest with yourself about what those passions are. And by doing that, hopefully, and fingers crossed, you'll be able to pursue the dream in your own stars. Thank you very much.
Thank you, Morgan. You inspire us all and give me faith in the care for our planet. Our next speaker is the lead scientist and senior exploration officer at the European Space Agency. What a treat for all of us. Bernard Fong has been leading the way on projects such as the Moon Village as executive director of the International Lunar Exploration Working Group, and was principal project scientist for SMART 1, the first European mission to the moon. Born in France, Bernard has a PhD in astrophysics and space techniques. He worked 3 years in Chile as an astronomer for the European Southern Observatory, the French Embassy, and as a professor of astrophysics. A researcher at French National Center for Scientific Research since 1986, he obtained the Habitation for Direction of Research in 1990. At ESA, since 1993, He is Senior Research Coordinator at the Research and Scientific Support Department. I have been fortunate enough to see his work in action at ESA facility in the Netherlands. I have to say the world needs many Bernard Fongs to continue pushing us towards thriving communities in off-world. Without further ado, please welcome Bernard Fong.
So, hello, cities in space. So, I am Bernard Fong, and I would like to talk to you about how we can become together villagers for the moon and Mars. So, I'm going to present you some activities that we have conducted with our Your Moon Mars team worldwide, where we have a young professional, but also veteran explorers working together to analyze data from the space, to develop instruments, but also to simulate how we are going to live and work on the moon and Mars. And I've put here their first name. So actually, I have been on the moon myself, in a way, because 15 years ago, we launched my baby to the moon. It was a spacecraft, Smart One, a small spacecraft of 1 cubic meter and with solar panels that we sent from Earth to the moon using a special technique, solar propulsion, and then we arrived at the moon. On our way leaving the Earth, we waved goodbye to the Earth. In particular, we looked at Europe, where I'm living, and then we went in a long trajectory toward the moon that used only some very small quantity of fuel, 60 liters of fuel to go from the Earth to the moon. We got into a Guinness Book of Records for that. But it took us 1 year and a half to arrive there. And when we arrived at the moon, we studied what the moon tells us about rocky planet. In particular, we see tectonics, wrinkles on the surface of the moon that tell us about how the moon interior has evolved. We see also craters, which are due to giant impact, bodies impacting the surface. We can even record all these bodies, and from the number of craters, we can determine the age of the various areas on the moon. And also there are volcanic features. So we have a volcanism on the moon that was taking place 3 billion years ago. And in particular, some of these basalt filled in some giant impact, and that gives this Maria, this dark spot you see on the near side of the moon. Also, with Smart One, we explored the polar regions, like incognita Luna that was not explored before. And at the end, we just landed a bit in a hard way on the surface of the moon with the impact, and we observed that from Earth. So one of our goals was to explore places, in particular in the polar region, which are not very well known, where we want to go in the future to put villages and even cities in space, cities on the moon. And in particular, near the south pole of the moon, there's a crater, Shackleton, and there are some areas that we have mapped which have a lot of sunlight all the time. And at proximity, we have dark area, very cold, where we have found traces of ice. So these are the places that we want to explore, where we put a robotic village and also human bases and cities in the future. So very close to the South Pole, we found a special area, which is just 1 kilometer square in the size, but that receives almost all the time sunlight. And there we could put a robotic village and then a human base and a city. So de facto, we have built a kind of moon village, a community of people interested by the moon. And so after our mission, Smart One, which was launched, the first one in the millennium, we had a few others. We have the Chinese mission, Chang'e 1, launched in 2007, and also the Japanese, Kaguya, in 2007. Then you had the Indian mission in 2008, and we had the US mission, Lunar Reconnaissance Orbiter, that was launched in 2009. So we created a community, like an orbital fleet, all around the moon, working together, exchanging data, and also new knowledge on the science of the moon, but also on places where we want to go and explore. So more than 20 years ago, we formed a community discussing, how are we going to settle and bring our human civilization beyond the Earth on the surface of the moon. We will do that step by step. First with this robotic precursor in orbit, then a robotic village, and where we have various landers, rovers, and then we'll have intelligent rovers that will deploy assets, food production system, energy production system, even habitat. And then human will come with their taxi, will be able to live there for a short time in an outpost. And then later we will have a full, sustainable, permanently inhabited base where we will use some of the resources. We call that the moon village. So we have started to do some tests also ourselves for this second phase for the robotic village. We built a small lander, so in the frame of the Google Lunar X Prize competition, and we tested how we could equip it with some instrument that we would use for science and exploration. Even we thought to put a telescope on the moon. So we have every year some young professionals joining us. So of all categories, we have astronomers, you can see. We have even some with rovers, some astronaut candidates. We have even biologists growing plants out of lunar soil. And we try to see how we could put that all on a small lander we could bring there even before we send humans. De facto, the robotic village has started because already in 2013, there was a lander and a rover that were deployed by China in a mission called Chang'e 3 on the surface of the moon. And ourselves also in Europe, we are making tests using some very intelligent autonomous rovers that can already work with landers. And here it's in a place on the Etna volcano that looks very similar to the moon where we have tested that. As you see, the Chinese were there and with their big lander, and 7 years after, this lander is still in operation. And then in 2019, they sent another lander and rover on the far side of the moon. And this year, in 2020, they brought a third lander, even with a rocket that allows on it to sample some rocks and soil from the moon and then bring it back to Earth successfully. So de facto, we have a number of landers, and this is going to follow. In the next years, we will have some of these landers and rovers that we are testing on Earth, we plan to send to the surface of the moon. This was some intelligent autonomous rovers that we operated at Etna, deploying some instrument, analyzing samples, and we are going also to deploy next June some radio antenna to observe the universe. If you look in the next year, we have a number of missions. So every year, several missions to be launched. Some are commercial missions. Now you can send some instrument yourself to the moon. You just need to pay the FedEx service or Amazon service to go there. It costs you about €1 million per kilogram. But you can miniaturize some rovers, some system, and you could send it that. Also, the US has developed a program, Commercial Payload Lunar Services, where a number of users can send equipment in these robotic commercial landers in preparation for future humans, also for exploitation of the moon as a place where we are going to live and work. And from 2023, 2024, we'll have other countries joining. We'll have China again with the sample return from the pole. We'll have Korea. We'll have Europe and Russia preparing for robotic mission. In parallel, we have been collaborating to send humans around the moon, and this is to take place in this Artemis Orion program, where ESA is also providing a module to bring all this capsule to the moon in 2023 with 4 astronauts. And then from 2024, we're expecting to have boots on the moon with the first woman on the moon. And we look towards the end of the decade to have a sustainable base, permanently inhabited. So we'll have humanity permanently present on the surface of the moon, like we had in the last 20 years, always some humans in orbit on the International Space Station around the Earth. So that's our views from the European Space Agency side. we are looking at humans in low Earth orbit, then around the moon, then on the surface of the moon, and then later human to Mars. We have a vision that to establish a sustainable presence on the moon, so that the moon village. So one intermediate step is that we could deploy some modules and then have some inflatable structure, and then using robot and 3D printer, we could build around to make them habitable for astronauts that will visit them. And then we will have a permanent installation. But the village is not only concerning what we put on the moon. We think that the village has to include the Earth. The Earth is a global village, with more than 7 billion people. And we have to work together to advance science, technology, peace, business, jobs, also education, international cooperation, and a renaissance. And so we try to involve everybody in this global village from Earth to the moon. So there are some technical challenges to install the moon base. You have to get there with a rocket safely and at affordable price. And you have to have for humans to be extremely safe. You have to communicate with the Earth. You have to operate this in extreme conditions on the moon. You have to survive both for the astronaut and for the equipment. And you want some mobility to explore around, to go and search for new places and also search for resources. And you will do that with humans very well assisted by robots, more and more intelligent. And those robots, some of them will be teleoperated from Earth. So all of you, if you like video games, you can have a job and teleoperate some of these hundreds of robots that will be helping the human on the surface of the moon. Also, the moon is a place where there are resources. We can exploit minerals, but also we find water ice. We can create water for the base, but as well, we can exploit from this water, extract hydrogen and oxygen, and we could use that for breathing and also for fuel rockets. And it's much more effective to launch a rocket from the moon because of the low gravity and the no atmosphere. But the new view is also, we do it for a large base of users, for the benefit of everybody on Earth, various countries, all generations, various disciplines, but also we try to involve some new space companies, even some non-space terrestrial companies, and all the individuals and companies on Earth that could start to develop activities on the moon, which is like an 8th continent of the Earth. So we also, at our phase, start some simulation. So these are some of my students. I log them down in the European lunar laboratory modules. And so during the day, they train how to communicate with the Earth. They analyze some samples. They have even a 3D printer. If they have forgotten an accessories, you don't need to wait 5 days, to get it back. You can print it. And then you have some laboratory area. We also did some tests in a volcanic area close to us where we tested how to operate with our lander, with an astronaut, with rovers in a place which was a volcano 10,000 years ago. So here you see it looks like the moon. In fact, this was in this volcanic area that we have used and tested our landers and astronauts. We also go in caves. And this cave, for instance, this is an ice cave where we look how to search for life. For instance, on Mars and on the moon, we could have ice caves, and there could be some presence of a prebiotic organism. So here we had a full protocol where the astronaut had equipment that was sterilized to search eventually for signs of microbial life from the sample. So this was a huge ice caves. But on the moon and Mars, the caves will be even bigger because of the low gravity. You can have big structures that do not collapse. So we even built a moon habitat in under a glacier. So this was a project between the various universities that ESA lab has sponsored, and the various groups build the habitat, the instrument, the life support system, or some various subsystem to communicate or for ensuring the well-being of the astronauts. Here, for instance, is a view of our igloo now, an igloo under a glacier, where we even had grown some plants with a robot. So you have a robotic arm that is picking the plants, and with artificial intelligence can determine when to plant, when to pick up, and when to give it to feed the astronaut. We even brought our lander on the top of the glacier. So we are also organizing campaign at places that look like the Moon and Mars. And Iceland is such a place. It's a volcanic world with glacier. And we have made a campaign to explore it, in particular some areas which are lava tubes, which we have found also on Moon and Mars, places where you could build habitat well protected from radiation, from particles, even from meteorites, and you could be well shielded and survive a long period. We have also done some simulation campaign to simulate Mars in the Utah desert using the Mars Society Desert Research Station, where every year we put some crew of 2 times 6 people for 2 weeks, and they perform laboratory and field research. They demonstrate some instrument, and they test how is it to develop an habitat for the Moon and Mars. We look also at the human aspect of the living there in an international crew, how we use our time and the safety and even the food. And at the same time, we offer that as an opportunity for young professionals to train and meet advanced researchers and also to communicate to their peers. As you see, on the top is some image of Mars we obtained with our Mars Express camera. And in the bottom are some views of this Utah site, very similar to Mars. So we had some instrument similar to what you would want in your Mars laboratory to analyze the rocks. And you analyze them in X-rays or with microscopes or in infrared. Also, when we go up, we have to put an extravehicular suit. So like we would be in the very tenuous atmosphere of Mars, 1% of Earth's pressure, or on the Moon, which is full vacuum. And there we tested how to deploy a radar or some rovers, or even to drill to get some sample in the subsurface. So on Mars, it takes 3 astronauts to really operate a drill. So it's more complicated when you have this EVA suit. So more recently, also, we have done some simulation in a moon base in Poland, where we enclose 6 astronauts for 2 weeks. You see, they are all smiling, they are all young and full of hope. And this is the picture before. And the picture after, they are even more happy because they have such a great experience of living on the moon for 2 weeks. And also, we fed them with plants grown in situ. And also, they could take care of the plants, which is a very good activity for the psychological balance of the crew. So more recently, we also have used a base in Hawaii. It's called ICES. It has been used for long duration simulation by NASA for looking how to spend 1 year on Mars. But now we use it for short simulation, 2 weeks on the moon, very similar to what we do with the Artemis program in the beginning, before we shift to 6 months long duration human mission. So I was there with Hank Rogers, the owner of this facility. He's also the owner of the Tetris game and is sponsoring these activities of exploration of sustainable energy and development. Here you can see we had some drone, we had some special equipment to analyze the samples. And then I returned there the year after. We built a mission control in a Blue Planet laboratory. And then we had a number of young astronauts that spent 2 weeks there. You can see the inside of the base. You have a briefing room. They are working. They're even cooking space food. And that's the view of this moon base, which is running on solar power and completely autonomous in a field of basalt like you would have on the surface of the moon or Mars. And so every day they plan some extravehicular sortie. Here they had to fix an antenna, and I monitored them in the comfort of my control room. Here they prepare for going out, their communication equipment, all their goodies and gadgets to communicate and document what they do during these sorties in extreme conditions. So they went on the basalt. Some of them are two geology students. They pick sample, analyze them, and they found some lava tubes entrance, and they started to discover what you have in these lava tubes on Earth, very similar to what we will do on the moon. And then they come back home and they eat this space food. This is just powder food. You put some water and then you try to reconstruct the taste of this food. But we had a French cook there. He was able to do bread even out of this space powder food. Here, the students in geology go back for another sortie and they pick the samples that they analyze to understand better, how this sample evolved under the effect of water and some 1 year on Earth would reproduce 1 million years of water on Mars. Here they explore, and eventually we went to visit them also with some cosmonauts from the International Space Station, and you see we try to build an international community learning to live and work on the surface of the moon and Mars. So now I would like to end that it's not only for scientists and engineers. If you feel more like an artist, we organize also activities for artists. We have a Moon Academy workshop where we had artists. One artist produced a robotic village, a very nice installation with light that he called Lunar Freedom. Another artist, she worked on a project to put a slime mold on the moon that survived well and could be the first life form before we sent more humans. And we organize also events in the middle of the city. We observe the moon, we observe the stars with our telescopes. We brought our lander, we landed in the middle of the city with some candidate astronauts. And even we do some events for Star Wars movie where we brought our telescope and we had observation on this night on the moon again, where all over the world there were more than 400 sites observing this beautiful moon with the telescope. Sometimes we even do music. So I am playing music myself. I play the viola or the guitar. So we have a band, classic and jazz. And so here we organize in the center of the city a concert about space and the music. And so we do this type of events. Even so, we have produced a global science opera. So that's a show that is produced by 20 classrooms all over the world, all together. And each of them is playing one scene in this opera. So one of the year in 2017, the theme was a moon village. It was a story of a girl, Sophia, that was born on the moon. In 2030, we'll have 10 people on the moon. In 2040, we'll have 100 people on the moon. So there will be the first baby born on the moon. And her name is Sophia. And and then we wrote the story. What is she going to learn at school? And what are the challenges of living there? She has the partial gravity, so you have to adapt to there. And she has a robot helping her. And at some stage, she's looking if she could come to Earth for the first time. Now, another aspect is how we can bring life to the moon. We have already put some microbial sample in space. This was an experiment I was involved on the International Space Station. We are looking to put also some of this experiment on the surface of the moon. So we have created a community of scientists, engineers, space artists, and you see all generations are involved in this group where we are trying to prepare what we will do to live and work on the moon and Mars. So on those words, I would like really to wish you good success for Cities in Space. And I'm looking at some stage to meet you, to see you on Earth before, at some stage, we could have some events on the moon. Thank you very much for your attention. Goodbye.
Thank you so much, Bernard. When I was fortunate enough to see your work firsthand and what you are doing at the European Space Agency in the Netherlands, I was thrilled and so excited of what you're doing to support young minds and supporting STEAM along with space. I was sold. I continue to be thrilled at the work you do in supporting these initiatives. Thank you for the good work. that you do every day. And now it's time, teams, to join in your question and answer breakout rooms with speakers Leon Vanstone, Amanda Messino, and Morgan Irons. Students who were not in line with the media waivers, please stay in our main conference hall versus jumping into the breakout rooms. For those staying in the main conference hall, I have a treat for you in the realms of space and film.
Did you ever wonder if all the stars were the same? Did you know that some of them pulsate, like Algol, the demon star? How did it get that name anyway? I'm going to show you how you can learn to see these wondrous objects in space for yourself, using our powerful robotic online telescopes, which are situated on mountaintops in Chile and in the Canary Islands off the coast of Morocco, where it is very dark and ideal for astronomy. One of our telescopes is designed just for looking at the sun, which you can see up close and personal every day, weather permitting, of course. You can check that on the satellite view for each observatory. Some of the telescopes are designed for looking at the planets, and some are for looking at objects that are far beyond our own Milky Way. And what's even cooler, you get to control these telescopes yourself, right from your home. And when you schedule a mission, other people can decide to come along. And of course, you can piggyback on their missions as well, because SLU is a huge global community of people exploring space together. And if you capture something amazing, you'll want to share your pic with everyone and tell them what you see. And then other members can like it and comment on it. And when they do, you'll earn gravity points, which is the scoring system of the massive multiplayer game that is powering SLU's group exploration of the universe. But alas, we're getting ahead of ourselves. So let's go back to the start with quests, where you will learn how all of this works. Since space is a pretty big place, we didn't want to send you out there without a map. Quests are like paths through space we have laid out for you, so you don't get lost along the way. They are exploration activities that will challenge you to hunt down phenomena in space, follow in the footsteps of famous discoverers, and build image collections like this poster of the Messier catalog, which is a wonderful showcase of all the images you will collect.
I'm so happy to welcome Dr. Jancy McPhee, Director of Human and Space Art Program, Director of SciArt Exchange, and the 2017 Permission to Dream Award recipient honoring space and STEAM education. Dr. McPhee has a BA in neurobiology and behavior from Cornell University and a PhD in biophysics from Brandeis University. She was a cellular and molecular neuroscience researcher in academia for 17 years before joining the National Space Biomedical Research Association and later University Space Research Association to manage various aspects of NASA's domestic and international space life science research programs. As Director of SciArt Exchange and the Human and Space Art Program, Dr. McPhee has created a new paradigm to involve students in science and technology by using art and the creative processes to fire the imagination. She is providing a new path to motivation and involvement in the sciences. Today, she will be sharing some of the most recent winners of the Mars Film Competition and discussing her good work towards STEAM, aerospace, and supporting young minds. Please welcome Dr. McPhee.
Hello, I'm Jancy McPhee, neuroscientist and executive director of SciArt Exchange. Our nonprofit invites students worldwide to learn about space and share their visions of the future through visual, literary, musical, and video art. We then use their multimedia artwork in displays, performances, and celebrations that engage others in a global dialogue about the future of space exploration. Through our activities, We foster communication, creativity, and collaboration skills, and inspire people about space development and exploration. Ultimately, we hope to prepare and bring together people to solve space, science, and technology challenges. So far, 11,000 people from over 60 countries have participated in our contests and campaigns, and over 3 million people have seen or heard the artwork in person in over 400 events worldwide. In this video collection, we share 2 short films from our early career Project Mars competition, and then a trailer celebrating the winners of our 2019 moon-themed Humans in Space Youth Art Competition. Great things happen at the intersection of science, technology, and the arts. It's exciting, it's important, and it's our future. We invite you to come join us.
Repeat.
सकुचाये मन इठले धीर धरो तुम धीर धरो मन धीर धरो तुम धीर धरो मन धीर धरो काहे सकुचाये मन इठले धीर धरो तुम धीर धरो मन धीर धरो तुम धीर धरो मन धीर धरो अपना रास्ता देख लिया जब खुद से चलना सीख लिया मन धीर धरो तुम धीर धरो अपना रास्ता देख लिया जब खुद से चलना सीख लिया मन धीर धरो तुम धीर धरो काहे सकुचाये मन इतने धीर धरो तुम धीर धरो मन 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 धीर धरो एक जाए एक जाए एक जाए एक जाए एक जाए दूजा जाए काहे सकुचाये मन इठले धीर धरो तुम धीर धरो मन धीर धरो तुम धीर धरो मन धीर धरो
Thank you, Jancy, for the amazing and creative films. The work of STEAMSPACE and SciArt students continue to astound me. They just keep getting better and better year after year. We will need this for where we're going, so thank you so much, Dr. McPhee. Our next speaker is a long-standing partner of STEAMSPACE and Cities in Space. Rachel Lyons, Executive Director of Space for Humanity, is all about the democratization of space and increasing human awareness of the world's problems and finding solutions. Space for Humanity will be sending 10,000 citizen astronauts to the edge of space over the next few years to give them the gift of perspective. If you have not visited their website to see these goals in action, I highly suggest you check it out. While STEAMSPACE works to create space settlers and space leaders here at Cities in Space, Space for Humanity is working to connect our future leaders and bring us all into the new frontier. The crews selected for their missions are diverse and uniquely qualified to share their experiences with broad communities and to the world as a whole. Please give your attention to Rachel Lyons.
Hello, everybody. My name is Rachel Lyons, and I'm the Executive Director of Space for Humanity. And for those of you who do not know Space for Humanity is a nonprofit organization that is working to pay for people from all over the world, all different walks of life, to go to space commercially, with companies like Virgin Galactic, Blue Origin, and the Space Perspective, which I'll tell you all about later, so they can go and see our planet, see and experience our planet as a planet floating in the universe, and then come back down and share that experience with their communities and with their friends. So I'll be talking more and more about why this experience is important and how that's going to be happening later on. And to start, I want to talk a little bit about my personal story. So, like I said, my name is Rachel. And as a kid, when I was your age, I never had an interest in space. It just wasn't something that I really understood as real. I learned about it in science class, but I didn't think about and understand that reality that we live on a planet floating in space. And when I was 19 years old, I watched a documentary called Cosmos. I'm curious if any of you have watched Cosmos with Neil deGrasse Tyson. And if you haven't, you should definitely watch it. So I watched this first episode of Neil deGrasse Tyson's Cosmos. In it, he shows our cosmic address. So just like you all have your own addresses, you live in your house, maybe it's like number 17 on the street, maybe it's Black Alder Lane. In the city, maybe it's Denver. In the state, Colorado. In the country, US. In the world. This address that shows where your place on our planet is. And just like there's an address for your home, there's an address for our planet Earth. So our cosmic address of the Earth, it's the Earth, which is in our solar system, which is in the Milky Way galaxy, which is in a local group of galaxies, which goes bigger and bigger and bigger and bigger until it's the observable universe, the universe that we can see. In this universe, just like our world is so big, it makes if you think about where your house is, it's that little tiny speck of sand on the planet. Just like that, our universe is incredibly massive, unfathomably massive. And our planet is smaller than a speck of sand. It's in the scale of the universe. It is tiny. And so I watched this documentary, Cosmos, and I could not believe how small and insignificant our little planet is. This planet where the entire history of human civilization is. This entire planet that feels so big for me just being a human. And it just completely transformed my point of view, because I saw how special it is. So that although it is so tiny and so insignificant in the scale of the universe, it is so freaking special. And we know So we know about a lot of planets. We've studied a number of the planets. We've studied all the planets that are in our solar system, and we're seeing lots of planets in other solar systems as well. And of the ones that we know, there's no other planet like Earth. There's no other planet that can harbor life. There's no other planet that can have life that after evolving for many, many, many years can now have humans, and now we're alive. And I saw how special it is for us to exist and for us to be here. And so, like I said, I was 19. I watched that episode, and I decided I needed to do everything I could to work in space. And actually, what I really wanted to do was to help us become multiplanetary. I wanted to help us go to other planets and live on other planets and build cities on other planets, just like all of you are doing. And so I went into aerospace engineering, and I studied aerospace engineering for while I was in college. And while I was there, I discovered this concept called the overview effect. And it's a term that's coined by an amazing man named Frank White. And what this overview effect is it's actually the astronaut experience. So astronauts, when they go to space, if you can imagine, so I just told you about this, the reality of us living on a planet floating in space and how amazing it is simply to know that. But can you imagine experiencing it? Can you imagine sitting on the top of a rocket and launching into space and floating up there in zero gravity, maybe on the International Space Station, which currently has 6 humans on it, by the way. Can you imagine being on the International Space Station, which is floating above our planet, and then looking out of the cupola, which is the biggest window on the International Space Station? It's a 360-degree view of the Earth. And can you imagine looking down at the Earth and seeing this beautiful blue, fragile in the vastness of space, ball of life? Can you imagine looking down and seeing that while you're floating separate from it? What would that be like for you? It literally will change the lives of astronauts. And they'll come back down with completely new perspectives about everything that is happening on our planet, from the environment to humanitarian issues, to even just their place in their local communities and the way that they treat and see their neighbors, because they see that this neighbor that maybe has a political sign that they don't agree with, or this neighbor or this person that honked at them. These are all just people who share this planet with them. So astronauts come back down with completely new perspectives, as I said. And what's incredibly exciting is that although up to now, there's been about 560 or 570 people who have been to space as astronauts, with NASA, with Russia, with a number of other countries. And soon that number is going to grow, and it's going to grow, and it's going to grow, and it's going to grow. And soon, with companies like Virgin Galactic, which is a person named Richard Branson's company, with that company, with Blue Origin, which is Jeff Bezos's company. I'm going to guess that some of you have heard of Jeff Bezos. With the Space Perspective, which is a stratospheric balloon company. So basically, they're balloons that go up to the stratosphere. And then with other companies too, there's space station companies. There's Elon Musk's company, SpaceX, that they're going to be going orbital and then also doing trips around the moon. With all of these companies, soon you will be able to buy a ticket and go to space. People will be able to do that. So just like about 100 years ago, people started to be able to buy a ticket and take an airplane flight. And it was this totally new and novel thing. And people were like, it was actually only like the wealthiest of the wealthy who were able to do it. And it was this amazing, luxurious experience. And it's going to be similar with spaceflight. So it'll be just the people who can afford it that are able to go, the very, very wealthy people. So these companies, Virgin Galactic and Blue Origin, could both be flying by the end of the year. So soon, regular people will be able to go to space with them. And so what Space for Humanity is working to do is sponsor or pay for people who wouldn't otherwise be able to afford that ticket to go and have these experiences in space. And it's important because of the overview effect. It's important because of the perspective that it gives people. And what these people will be doing is coming back down and using this perspective to create good in the world. So they'll be using this perspective to encourage people to treat the planet with more love and respect, because they'll see and understand how fragile and how special that our planet is, and how much, and that we have finite resources on it and we must take care of it. And they'll also come back down and they'll share that we're all humans sharing this planet together. And we must act like that. We must treat others with love and respect. And we must understand that we're all simply humans on this planet. So that's what the astronauts with Space for Humanity will be doing. So it's really, really exciting, because for those of you who have perhaps dreamt of being astronauts, or maybe you haven't even thought about it, but now maybe you're thinking like, that could be possible in the future. It really, really will be possible soon. And what's really exciting about it, in the longer term, companies like Virgin Galactic and others, they'll be doing point-to-point travel. So this is going to completely revolutionize travel, because people will be able to fly from their space, go up to space from their spaceport in New Mexico, go around to the other side of the planet. So he go over to Australia. It'll take them, when you're in space, it moves really quickly. So you'll be able to get over there in like half an hour, 45 minutes, and then land. So because of space travel, because of what these companies are doing, you will soon be able to go up to space, go around, come back down. And you'll be able to travel from one point in the world to another in less than an hour. So if you all are interested in being involved, if you all want, if you've dreamt of being an astronaut, or like I said, maybe you haven't, and maybe you're just starting to be curious about it, there's so many ways for you to get involved. With Space for Humanity, for example, we have so many ways to engage online. We have a lot of online content. And once you're 18, you can apply to our program. So you can apply to be an astronaut, to use this experience for good in the world. And if you're interested in having a career in STEM or STEAM, if you're interested in using your brain to help us go to space and to help us become a multiplanetary species, there's so many ways that you can do that. There are so many jobs right now. There's so many opportunities. There's organizations like this one that you're with right now, STEAMSPACE. There's an organization called SEDS, which stands for Students for the Exploration and Development of Space. There's one called SGAC, which is the Space Generation Advisory Council. There's a lot of, just go out of your way to meet people who are working in space, send them emails and message them on Instagram, ask them how they got their job, get involved with projects like you are right now, and just continue doing it, and really don't give up. Just keep doing it, keep going out there. And really the way that I got my job and the way that I'm doing what I'm doing is through reaching out to people and asking them, how did you get where you are? And can I learn from you? And not stopping to learn. So if you guys are interested in Space for Humanity and learning more about us, you can go to our website. It is spaceforhumanity.org. Thank you so much, all of you. Amazing work with your Cities in Space projects. And I'm excited to see you all working in the space sector in the future.
Thank you, Rachel, and thank you, Space for Humanity, for your inspiring work and supporting all of humanity in the push towards the cosmos. We look forward to seeing the giant leaps you will be making over the next couple of years. It is my honor to introduce our next speakers. This dynamic duo, Leon Vanstone and Amanda Messino, have been part of our STEAMSPACE community for several years, including have their college students mentor ours in years past. Now, we've heard from some amazing professionals about this golden age of space that we are living in right now, and we are going to now hear about some of the challenges we will face to get there, to get out there, and what happens once we get there and what challenges we will face then. So I'm very excited to say that some of these challenges we've already seen in many of our projects that our judges have been working on for this year's Cities in Space. It surprises me, it delights me, And it makes me hopeful because it's you students that we are relying on to be our future leaders in space and to help take on these challenges with pride, excitement, and enthusiasm. Leon Vanstone is a PhD in aerospace engineering and a research associate at UT Austin, a rocket scientist, and the founder of Texas Rocket and Engineering Lab at the University of Texas at Austin. Amanda Messino is Associate Professor in Biology at Huston-Tillotson University in Austin. She heads up the Department of Natural Sciences at Huston-Tillotson as well. Together, Leon and Amanda make up a brilliant duo, bringing aerospace, science, biology, and just a ton of fun to all students, including you. One project in particular you should all look up is called the Dumpster Project. It might be what you're thinking. This endeavor is all about renovating dumpsters to make habitats. It's pretty amazing. Amanda Messino has a strong focus on sustainability and the environment, and we see that in the work she's doing. She's the leader for the Dumpster Project, so I encourage you to go check it out and also maybe ask her some questions about it in your breakout rooms. So now, please welcome Leon Vanstone and Amanda Messino.
Hello everyone, my name is Dr. Leon Vanstone. I'm a rocket scientist. Talking with me today as well is Amanda Messino. She's a rocket biologist. Don't ask how that works, it's complicated. We're here to tell you exactly why it is that space wants you dead. When most people think of space, they think of being in space, they think of something like this. You know, here you are, you're an astronaut, floating tranquilly. It's really nice looking down on these beautiful vistas over the wonderful, warm planet Earth. And planet Earth is lovely because planet Earth does not want you dead. You can be on planet Earth. It's very comfortable. Most of us are here now, in fact. But outside, this blackness, this void of infinite space out here, that wants you dead. It wants to suffocate you and it wants to freeze you solid. And the only thing between you and certain death are the tiny thin walls. Right there, you see that? Right there, the thin walls of your spaceship, which constantly wants to explode. Now, if you ask me, this is not a tranquil situation. It's a bit more like this. It is stressful. It's one hell of a joyride, and everything around you constantly wants to explode. Now, before we talk about the myriad ways that space wants you dead, we need to talk about where space is and how we get there. So, where is space? Let's imagine we had a baseball and we want to put the baseball in orbit then of the Earth. Okay, well, what does that look like? Well, in fact, if you want to be orbiting the Earth, you need to be doing 20,000 miles an hour. That's really fast, 20,000 miles an hour. Now, the fastest many of you have probably been is, 60, 70, 80, maybe even 100 miles an hour, right, on the highway. But no, in space, you have to do 20,000 miles an hour. That's incredibly fast. In fact, it's so fast that you need to go that quickly outside of the atmosphere, because if you moved that fast inside the atmosphere, you just melt. You see, when the spaceships re-enter into the Earth, all the fire and the heat that comes off of them, that's what happens when you go that fast within the atmosphere. Nobody likes melting. That's why we don't do it. So you have to be outside. Okay, so where does the atmosphere end then? So you can fly outside of it, right? When, if you're going to do 20,000 miles an hour, which is super fast, where does the atmosphere end? And in fact, it ends at about 160 kilometers off the surface of the Earth. Now, the atmosphere doesn't just stop, right? It's not like water in a glass where suddenly just there's a water level and outside of it there's no water. No, that's not how the atmosphere works. It just gets thinner and thinner and thinner and thinner. But most people agree it's 160 kilometers up. And, appreciate most of you are probably working in freedom units. So that's 100 miles, right? That's where space ends. So space is 100 miles up. That's not very far, right? 100 miles isn't very far. Doing 20,000 miles an hour. Now that is very fast. That's the thing about space. It's never that far away because it's always trying to kill you, right? I live in Austin, Texas, and in fact, if the International Space Station were over me right now, it would be closer to me than the Alamo, right, in San Antonio. That's how close space is. Okay, so now we kind of have an idea of what space is. It's very close, but also very fast. How do you space? How do you get there? Now, most people would recognize this. This is a rocket, and most people would agree rockets are awesome. Right. Rockets are not awesome. In fact, rockets are terrible. You should never ever use a rocket to go anywhere or do anything unless you absolutely have to. No one flies across the ocean in a rocket. You use an airplane. And let's look at both of these vehicles. Let's look at this airplane over here and let's look at this rocket, right? So both are very complicated vehicles. They really are, right? Here's a rocket engine. You see diagrams like this. Things look very complicated. This is a plane engine. Also very complicated. Both complex machines. This is the cockpit from the shuttle orbiting the Earth. You can see all these buttons and dials and indicators. Looks very complicated, but that's just what planes and rockets look like. Here's the cockpit of a Concorde. It's complicated too. Dials and buttons everywhere. That's just what complex machines look like. Planes are very expensive. Planes cost $350 million to build. Modern rockets, not the Saturn V, certainly, which is this one here, but a Falcon or a Falcon Heavy, these vehicles are more like $50 to $100 million. So it costs more to build an airplane than it does to build a rocket. An airplane might fly 35,000 times. That's an enormous number of times. The rocket typically it flies once. With SpaceX and with Blue Origin, people are looking at flying rockets maybe 10 to 100 times. But still, let's do a quick bit of math, right? Here is our airplane. It flies 35,000 times. It carries about 800 people, costs $350 million to build. So it costs $12.50 per ticket, right? So if you buy a plane ticket, $12.50 of the cost of that ticket pays for the aeroplane. It costs you more to get the Uber to the airport than it does to pay for the vehicle that flies you all over the world. And I don't want to spend too much time talking about the difference about how rockets fly and how airplanes fly. There's some very important magic that's involved, but the takeaway from this, rockets are inefficient. See all this fire that's coming out the back here, an explosion, right? That makes them very inefficient. Fire and explosion doesn't come pouring out of your car. It doesn't come pouring out of your airplanes. It doesn't come pouring out of trains. Those are efficient vehicles. This is not. Right, and that's how you know. And to give you an example, right, a large rocket might weigh as much as 1,000 tons, and about 900 tons of that mass is going to be fuel because the rocket's so inefficient. It needs all this fuel, right, of 900 tons of it to get it into orbit. Now, that's 90% of the way to the vehicle, and in fact, only maybe 10 to 50 tons of the vehicle, of this 1,000-ton vehicle, are going to be satellites and payload and people and all this other stuff that you have to get up there, right? That's crazy. And here's an example, right? If we look here, this is a launch of a SpaceX. That's a 20-ton cargo capacity, right? Like a Falcon, right? Falcon rocket, 20 tons. And just a single Falcon, that will run you about $50 million a launch. So if you do the math, that's $2.5 million per ton. $500,000 ticket price to get yourself something like to the moon. Now, if we're saying that we want humanity to be a spacefaring species, which I think we do, right? You can't just let a few people go to space. We all need to go. Well, there's 7 billion people, 500,000, ticket price per person, $350 trillion to send everyone to space once, right? These are some posh astronauts. And in fact, all of the money in the world, if we took all of the money in the world and added it together, if we just took everyone's money, that's $100 trillion. So it actually costs 3.5 times more money than there is in the entire world to send everyone to space once, right? That's just mind-boggling. That's far too expensive, right, compared to the cost of something like a plane ticket. There is also another disadvantage to having so much fire and explosion, and it's this. I'll show you this quick video. No. That wasn't supposed to happen. The top fell off. That definitely was not supposed to happen. They explode all the time. In fact, the current safety rating for rockets is somewhere between 1 and 5%. That means about 1 in every 20 of them blows up. They are nowhere near safe enough for everyone in the world to go, but unless you want fancy killing 1 in 20 people. No more of that. Now, the alternative to all of this, of course, is that you'd like to have all of the advantages of a plane, where it's really reusable and flies very often and all this other stuff, and all of the advantages of a rocket, which is it's capable of going to space at 20,000 miles an hour, 100 miles up. It is potentially doable, but it's very difficult. We don't have a solution for that. So currently, if you do want to do 20,000 miles an hour, 100 miles up, the solution is this. And ultimately, this is what makes rockets special, is that they are capable of doing something that no other vehicle currently can. They're maybe not perfect. Maybe those rockets are also trying to kill you as well, as much as space is trying to kill you, but nonetheless, it is the only way. In conclusion, Rockets are bad. They are trying to kill you and they are inefficient, right? But rockets are also special. They're the only way that we can get to space, which, by the way, is trying to kill you. Everything we have talked about so far is just covering how we get to space, right? Once you get to space, you need somewhere you can live. If you're going to be in the Capella looking down on the planet Earth, you're in a spaceship. But actually, the planet Earth as well, it's also a spaceship. It is a vehicle in which humans travel through space. It keeps us safe from space, which is always very close and trying to kill you. All right, so hopefully by this point, it's pretty clear. Space wants you dead. So Amanda's now going to talk to you about what it is we can do about that.
So Leon's just told you about all of the ways that traveling in space can be dangerous. I'm going to talk about a different way that space wants you dead. My name is Amanda Messino. I'm a biologist, and I'm going to talk about the ways that your biology presents some important challenges for space travel and for living on different planets. One of the biggest ways that our biology presents some challenges in space has to do with radiation. Now, here on Earth, we are protected from some sources of radiation, from galactic cosmic rays or from solar energetic particles, these particles that are emitted during solar flares and other solar activity. We're protected from these by the magnetosphere, which you see here as sort of this blue shield around the Earth. And that magnetosphere repels these particles and keeps them from reaching the planet. Any kind of space travel would take humans outside of the magnetosphere. And so in that environment, they would be bombarded with radiation. And that radiation can cause immediate damage to the body if it's in a high enough dose. It can cause fatality if it's in a high enough dose. And over the long term, it causes damage to DNA. So it can kill you outright, or it can damage your DNA in such a way that you cause mutations that would be passed on to your offspring, or which could cause cancer and then lead to your death. So radiation is a significant challenge we face when looking at space travel or looking at living on planets that don't have a protective magnetosphere the way that the Earth does. Another challenge that we have to think about when we look at living on other planets has to do with the physical environment. Many people are looking at Mars as a place that we want to not just explore, but somehow colonize. And yet we have some challenges to face with Mars. We've studied enough of its surface now to know that there are several chemicals in the Martian soil that are very toxic and damaging to life. The one on the left, perchlorate, is a chemical that has an oxidizing action. That means that it behaves like bleach. The one in the middle is iron oxide, or rust. And the one on the right is hydrogen peroxide, that stuff that comes in the light-proof bottles that you use to disinfect wounds. So each of these is toxic on its own, and then they all react with each other to make even more toxic compounds. All of these present a problem and a challenge to life on Mars. They would be in the dust, and they'd be in the soil, and so anything that you try to grow there would pick up these chemicals or be inhibited and not even be able to grow. In the movie The Martian, Matt Damon's character survives on Mars by growing some potatoes, using Martian soil and some fertilizer. Now, if this was done in reality, the perchlorate would get sucked up by those plants and poison them. And if you ate the plants, you would pick up the poison too. So both the potatoes and Matt Damon would have been poisoned by the Martian environment. So this is another set of significant challenges to our biology. But these are not even the biggest challenge. The biggest challenge is something more fundamental, something that underlies both of these. The biggest challenge to traveling in space and living on other planets is this guy, Charles Darwin. Not him specifically. Charles Darwin isn't going to be hiding behind a boulder on Mars to jump out and say boo. The challenge is the process of evolution that Darwin first described. Now, evolution occurs when groups of organisms change as they interact with and respond to their environments. And over time, this gives us new species. As an example, if we have this population of mice that have two different coat colors, sort of the light and the gray, and they live in an environment where the light coat colors are more visible to predators, well, those organisms are going to get picked off, and the survivors are going to have more of the dark coats, which means that over time, the population is going to be dominated by the darker coats. They're more successful in the environment because they blend in and the predators can't hunt them. And so given enough time, the percentage of the beige coat will go down and maybe will just be eliminated. This is evolution, changing, in this case in response to a predator. But our bodies evolve in response to all of the conditions of our environment. So our bodies, our human bodies, have evolved over hundreds of thousands of years to our atmosphere, to the amount of water on our planet, to the kind of soil characteristics on our planet, and importantly to the force of gravity on our planet, which shapes the evolution and thus the behavior and biology of so many living things, like these seeds that know to put their roots down and their leaves up even when they're not in the sunlight because they're responding to gravity. This is a significant shaping factor. What happens when we take it away and when we put the human body in conditions where there's no gravity in space or reduced gravity on another planet? We have significant changes to many systems when we take gravity away. For example, bone normally has this honeycomb structure to give it really a lot of strength for the amount of space. And this honeycomb structure is maintained by these cells called osteocytes that live in the bone, and they sense force, and they sense part of the force that gravity puts on our bodies so that they can make the bone stronger in areas where it needs to be strong. If we look at bone under the microscope, this 3D structure is really apparent. Again, these little chambers are all adding strength. You take away gravity, like for astronauts in space travel, and their bone wears away. It starts to degrade without gravity to make it strong, and it ends up looking like the bone of someone with osteoporosis. Another system that's heavily affected is the muscle. Muscle in the body needs to react to a force in order to stay strong. And even when you don't think you're doing any exercise at all, your muscle is working. As you're sitting here listening to me, your muscle is holding you upright in your chairs against the force of gravity. That's work. And if you take that away by removing gravity, muscle atrophies. Astronauts lose 20% of their muscle mass in space. Astronauts on the space station have to exercise 2.5 hours a day just to maintain their muscle mass. This is fine as a short-term solution, but it's not something that we can manage doing over the long term if we're living on a planet with reduced gravity. The brain is affected as well. The brain is normally surrounded with this cerebrospinal fluid that cushions the brain and keeps it from sort of hitting the inside of your skull. And that fluid surrounds your spinal cord as well. If we were to look at this brain in a scanner, you'd see all of these white spaces that represent where the fluid is normally. After some time in space, astronauts' brains look like this, where you've lost all that fluid space and the brain is sort of smushed up against the inside of the skull. A big challenge because the fluid has moved around due to the lack of gravity. This affects the eyes too. In this little picture, you can see that the optic nerve, which also has fluid around it, has become bent. And astronauts, many of them experience visual problems, some from the change in gravity and fluids, some from the radiation in space. So all of these are significant challenges. Again, our biology has adapted to one set of conditions on Earth, to our conditions, to our force of gravity. If you take that away, we have to think about the ways we're going to protect against that or help people recuperate from that. And these are only a few of the examples. We also have changes to the cardiovascular system as fluid shifts upward in the body, the immune system, the endocrine system, and the stress response. All of these things change. In fact, we know that the changes even go down to the level of your DNA. From studying, in particular, Mark and Scott Kelly. Scott spent a year on the space station while his twin brother Mark stayed here on Earth. So it was in a lot of ways a perfect experiment. You had these people who were genetically identical, and then we could compare, what if you just changed one thing? You put Scott in space for a year, what would happen to his body and what would happen to his DNA? And among the changes, that some of which I've already described, one of the biggest surprises was that Scott's DNA changed in a way that his body responded to space as if it had aged. At the ends of your chromosomes, you have these materials called telomeres that cushion the ends of the chromosomes. Scott's had worn away in space. So evolution is a challenge. Evolution can also be the solution. Evolution has given us tremendous creative power to think of technological solutions like artificially generating a magnetosphere, and also has given us the ability to learn from other organisms that have evolved to harsh conditions, like this tardigrade that can survive radiation. So in this way, we're going to be able to use evolution to overcome the limitations of our biology as well, and hopefully learn how to adapt to a new environment that'll make us evolve in new ways.
Thank you so much, Leon and Amanda, and thank you for the great research you are doing to propel us towards space and supporting sustainability. These are needed, and we are thrilled that you guys got this. And thank you for pointing out our challenges, because these are things we will need to be focused on if we are going to be moving into settlements off-world. Next up is one of our youngest great minds in space. Students, here is a treat for you and an inspiration, listening to a fellow peer and high school student. We are thrilled to host Bella Stoffel, head intern at Stoffel Aerospace. Stoffel Aerospace is a rocket company which supports and promotes affordable payloads and reusable systems, and is developing balloon-based orbit launch systems using solid rocket engines and weather balloons. Their balloons carry the rocket to 100,000 feet, where the rocket then launches to place the satellites into low Earth orbit. This on-demand access of low Earth orbit will be the first of a kind, providing mass-produced rocket systems, often decreasing cost per pound to orbit significantly. Bella has spoken in Washington, D.C. on the potential for an affordable space program. She's a STEAM advocate. She loves 3D printing. And did I mention she's in high school? Oh yeah, I did. So let's all listen to her story.
Hey guys, I'm Bella Stofiel. I was a speaker last year and I just got invited again to speak to you guys this year, and I'm so excited. I am a teen influencer and STEAM educator. So I go around and I talk to everybody from ages like 10 up to adults. And I have been able to do this twice, and it's super exciting to me. So I'm just going to give you a little background on myself, and then I'm going to get started. So I'm Bella, as you already know, and I got into the space industry when I was 5 with my father. We started a business, and it's developed into something pretty big. We work alongside NASA and SpaceX. So that's how I got into the space industry. And then around 10, when I was 10, 9-ish, I got into the STEAM industry, and I was able to start going out and doing speeches. My first ever speech was at Venture Cafe in St. Louis, Missouri. So that was super fun. I was 10, and there were like 20, 30 people in the audience. So for my first speech, that was like pretty big for me. Last year, I went to ISDC, and I was speaking in front of a couple thousand kids, and I was telling them about their goals, and I was congratulating them because most of them were winning awards there. So that was super fun. And then after that, I went straight to Seattle, and I did a speech there, and I was actually competing in a business competition. So basically, you promote your business. You tell everyone what your business is about, and there's 2 awards you can win. You can win the overall award where the judges pick you, and then you can win the audience award. So I won the audience award, and it was super exciting because my whole business won $1,000, and that really helped us. So I'm going to be talking to you guys about your goals and how you can achieve your goals and the motivation that you're going to need, because motivation right now is super hard, especially during the pandemic. And I know for me as a high school student, I've had really, really bad struggles just trying to get an essay done. When I was writing my speech, actually, because I have a couple of bullet notes that I'm using, I was in the middle of an essay and I just needed a break from it. So I just went and I did something else, which is this. And then I came back to it and I was able to finish the essay within that hour. So what I use for motivation is my main goal. My main goal is to graduate high school. For my junior and senior year, I want to try and go to a governor's school, which is a state high school, a residential state high school. You basically stay at the high school, and it's for arts. So you've got theater, you've got art, you've got baking, and then you've got science and math. And I want to go for art because that's going to be my minor in college. So for my college, I want to graduate college with a major in marine biology and a minor in fine arts. Now, some of you are like, why does she want to major in marine biology? She's like, space industry, how does that have to do with space industry? And I want to be a marine biologist so that I can study the ocean, because we know more about space up there than we do about our ocean. And that's just like really surprising to me because our ocean is way more closer. So the way that my marine biology is going to go into the space industry is basically when we do find, because there's no doubt in it, when we do find water on planets, possibly Saturn, possibly somewhere else in a different galaxy or a different solar system, they are going to need not only astronauts, but they're also going to need marine biologists, because the astronauts may not have they may not have the knowledge on what kind of animals could possibly be living there, what kind of bacteria are there, how they could scuba dive. They may not be as experienced as a marine biologist would. They may know those stuff, but they may not have like experience in the field. So that is my main goal. I want to be a marine biologist, and I want to be able to go and explore a water planet and find life and stuff. So right now, I want you to think of your goals. I want you to think what your main goal is. And if you don't have one, that's totally fine. I didn't find mine until I was 13. And that's not a big deal that you don't have a goal. You may not find your goal, your main goal, until you're like 17 or 18, and that's totally fine. So think about that goal that you may or may not have right now. Okay, so to achieve my goals, I have steps along the way, and I have steps in between those steps to get to the next step. So my first step was getting scuba dive certified, and I got that in January 2019, so last year. That was my first step. And the step to get to that first step was being able to research scuba diving. I was having to research where's the best places. Do I want a PADI certified? Do I want a PADI certification, or do I want something else? Do I want international or just national? And that was the step of research to get to my first step. My second step now is to go to a marine biology camp and study under a full-time marine biologist. And I'm actually going to try and do that this year. So that's going to be pretty exciting. My next step, I haven't really figured out, but I'm pretty sure it's going to go to college. So for your steps, what are your steps to get to your goal? If your goal is to be an astronaut, you're probably going to want to get scuba dive certified, because that's one of the requirements so they can train you. So that may be your first step. You may have to go through the same thing I did. Your first step, if you want to be a nurse, would be going and trying to research that and interviewing like nurses near you or doctors near you. So what are those steps, and how are you going to achieve those steps? That is basically your motivation. So not right now, you don't have to do it right now, but later on, if you want to, I want you to go and talk to someone about your main goal and the steps you're going to take to get to that goal, and write your main goal down on the top of a page. So like I have mine right here. So write your main goal on the top of the page, and then the steps you're going to need to take, and then how you're going to achieve those steps. So your goal is probably going to be the biggest motivation for you. So if you're not having motivation to do your schoolwork, you're not having motivation to get out of bed, to do your chores, if you have any of those, you just want to think about that main goal and how, if you don't do this, how is that going to affect the long-term like trial to get to that main goal? It may slow you down. If you don't do your schoolwork, you may get possibly held back, and that would slow you down a year to get to college and getting to a degree. So a motivation that I use is my goal, but a second motivation is my family. If I didn't do my schoolwork, my family would be let down. If I didn't do my schoolwork, I would let down myself, not just my family. I would let down myself and my motivations. And to me, that's just really hard because I hate letting down other people, but when I'm letting down myself, that just hurts. And so the motivation, I want you to find your motivations, whether it's your friend, whether it's your family, whether it's yourself, whether it's a stuffed animal beside your bed. That may be your motivation. Your motivation can be huge, your motivation can be small, it doesn't matter. All right. So another thing I want to go over is the fact that no goals are too big and no goals are too small. Your goal to you may seem impossible, but it's not. Nothing is ever impossible. So, like, if your goal is to live on a different planet, that's not impossible. You're going to have to work for it. You're going to have to work extra hard than maybe some other people, but it's not impossible. A quote that I like that I have actually used as motivation for other people is, you live on this amazing floating rock, so live life the way you want to live it. And if there is a possibility that you may live on a different planet, like for instance Saturn or something, you can do it. So I believe that something like that may happen in the next century or so. And I think it's going to be super cool when that does happen. So just think about your goals, think about how you're going to achieve your goals. And I just want you to think about that goal and how you're going to achieve it, because that's just going to be the biggest thing in your life that you're going to want to do. Keep your goals. If your goals change over time, that's going to be perfectly fine. So that's all I have for today. I thank you guys for listening to me, and I know I rambled a little bit, but thank you guys, and I hope you have an amazing day.
Thank you, Bella. You have done so much the past few years in your few short years. We cannot wait to see where you go over the next few. Thank you for inspiring the world towards the stars. And now it's that time again for teams to join your question and answer breakout rooms with speaker Natalie Mendez as well as speaker Rachel Lyons. Please remember that students who were not in line with the media waiver, please stay in our main conference hall versus jumping into these breakout rooms. For those staying in the main conference hall, we will have another fabulous speaker discussing film, dreaming of space, and what we will do when we get there. Our next speaker, Jeff Smith, has been a great friend and supporter of Cities in Space from the beginning. He's been a guest speaker and a judge, as well as an exhibitor, and been all hands on deck for our in-person events. Jeff is a material control analyst for Ball Aerospace in Boulder, Colorado. He also oversees Ball's summer internships. Active in the space community for years, Jeff has volunteered for and worked with numerous space organizations, including the Space Frontier Foundation, the National Space Society, the Space Finance Group, Mars World, and is a member of the American Institute of Aeronautics and Astronautics, the National Space Society, and the Space Frontier Foundation. Please welcome Jeff.
Hello, Cities in Space. Hope you all are enjoying the virtual conference. So I found this YouTube video called Wanderers by Eric Wernquist, narrated by Carl Sagan, and thought we all could use some inspiration right about now. As you watch this video, I want you to think about the role you will play in helping to make this future a reality. Will you be the rocket scientist that discovers a faster propulsion system, an engineer that builds cities on Mars, an entrepreneur that owns the next great space company, an artist who shows a vision of the future, like the video you're about to see, or a teacher like Holly that inspires the next generation of space explorers? Now, I know the road ahead may seem long and difficult at times, but a marathon is just a collection of steps. So I encourage you to take one step each and every day towards reaching your goals, and no matter the challenges that may lie ahead, never stop reaching for the stars. Hope to see you all again soon. Enjoy the rest of the conference, and I hope you like the film. Take care.
For all its material advantages, the sedentary life has left us edgy, unfulfilled. Even after 400 generations in villages and cities, we haven't forgotten. The open road still softly calls, like a nearly forgotten song of childhood. We invest far-off places with a certain romance. The appeal, I suspect, has been meticulously crafted by natural selection as an essential element in our survival. Long summers, mild winters, rich harvests, plentiful game. None of them lasts forever. Your own life, or your band's, or even your species might be owed to a restless few drawn by a craving they can hardly articulate or understand, to undiscovered lands and new worlds. Herman Melville in Moby Dick spoke for wanderers in all epochs and meridians. He said, "I am tormented with an everlasting itch for things remote. I love to sail forbidden seas." Maybe it's a little early. Maybe the time is not quite yet. But those other worlds, promising untold opportunities, beckon. Silently, they orbit the sun, waiting.
Thank you, Jeff, for your ever insightful words and the information you bring to us about our future in space.
Oh, golly, I remember going through launch, which is an overwhelming experience. The engines cut off. I felt myself floating out of the seat. I floated over to the window, looked out, and we were coming up over the coast of Africa. And that's when it hit me. I'm in space. And, you know, I just got incredibly excited because it's something I had dreamed about since I was 6 years old.
I think you start out with this idea of what it's going to be like. And then when you do finally look at the Earth for the first time, you're overwhelmed by how much more beautiful it really is when you see it for real. It's just like it's this dynamic, alive place that you see glowing all the time.
It was truly incredible to be up there doing what I always wanted to do my whole life, and then to kind of glance back at our planet and see that view was just tremendous.
I can only describe what I've seen. You know, looking down at the Earth and you see that line that separates day into night slowly moving across the planet. Thunderstorms on the horizon casting these long shadows as the sun sets. And then watching the Earth come alive. And you see the lights from the cities and the towns.
The events you see from space, like flying over thunderstorms, looking at them from the top, were spectacular. Like a fireworks show going on, and you're looking at it from the very top.
You know, shooting stars going below us, or you know, dancing curtains of auroras. It's just very hard to describe all the, you know, the colors, the beauty, the motion.
My job as lunar module pilot was to be responsible for the lunar module itself and responsible for the science on the moon. So when we started home, I had a little more time to look out the window than the other guys because most of my responsibilities were completed. We were in a particular mode called the barbecue mode. So we were flying like this and rotating like that. What that caused to happen was every 2 minutes, a picture of the Earth, the moon, the sun, and a 360-degree panorama of the heavens appeared in the spacecraft window. And I had studied astronomy, and I had studied cosmology, and fully understood that the molecules in my body, and the molecules in my partner's bodies, and in the spacecraft, had been prototyped in some ancient generation of stars. In other words, it was pretty obvious from those descriptions, we're stardust. Well, that was pretty awesome and powerful, particularly since I had a little more time at this point to be reflective and to think about it.
Awe, I think, is one of those words that you have a better understanding of once you see it, too. I felt like, you know, using the word awesome was totally appropriate when it came to describing what the planet looks like.
To have that experience of awe is, at least for the moment, to let go of yourself, to transcend the sense of separation. So it's not just that they were experiencing something other than them, but that they were at some very deep level integrating, realizing their interconnectedness with that beautiful blue-green ball.
And this is why the astronauts, particularly in the International Space Station, often say that much of their free time is filled with what they call Earth gazing, just staring out at the Earth. They can stare for hours because the changing scenery, the interactivity of the biosphere, all of this has an incredible aesthetic impact.
The beauty of seeing Earth as a planet, as opposed to being down here among it, is a wonderful experience to then start to get into what we call the big picture effect or the overview effect.
I was flying cross country from the East Coast to the West Coast in the 1970s. And I was looking out the window, and as I was looking down at the planet, the thought came to me, anyone living in a space settlement or living on the moon would always have an overview. They would see things that we know, but we don't experience, which is that the Earth is one system, we're all part of that system, and that there is a certain unity and coherence to it all. And I immediately called it the overview effect.
You do, from that perspective, see the Earth as a planet. You see the sun as a star. We see the sun in the blue sky, but up there you see the sun in a black sky. So yeah, you are seeing it from a cosmic perspective.
We've been evolving from the beginning of civilization to a larger and larger perspective of life on the Earth. But the next natural evolution is understanding the life in space. That is, the fact that the Earth, as Buckminster Fuller used to famously say, is a spaceship, spaceship Earth. We are in space already. It's just that we haven't brought that into our perspective as we live here on Earth. The overview effect is simply the sudden recognition that we live on a planet and all the implications that it brings to life on Earth.
When we look down at the Earth from space, we see this amazing, indescribably beautiful planet. It looks like a living, breathing organism, but it also, at the same time, looks extremely fragile.
Because you go outside on a clear day and it's the big blue sky, and it's like it goes on forever, right? And how could we possibly, put enough stuff into it to fill it up with things that really change it? And yet, you see it from space, and it's this thin line which is just barely hugging the surface of the planet.
Anybody else who's ever gone to space says the same thing, because it really is striking and it's really sobering to see this paper-thin layer and to realize that that little paper-thin layer is all that protects every living thing on Earth from death, basically, from the harshness of space.
There's this very poetic concept that a lot of people express, that there are no boundaries from space. And I've heard a lot of my astronaut colleagues say that. Unfortunately, it's not true. You do see boundaries. They're mostly the result of human impact. You can see erosion, clear-cutting of forests, and it's a long litany of environmental impact that we've had on our planet. And that's something which, when you see it from a cosmic perspective, makes you really appreciate the concept of spaceship Earth, and that we're all here together.
After I came back and tried to understand what this experience was all about, I could find nothing in the science literature about it, and nothing in the religious literature that I looked at. So I turned to the local university and asked them to help me with what I saw. And when they came back to me a few weeks later and said, well, in the ancient literature, we found a description called Salvakapa Samadhi. And they said that means that you see things as you see them with your eyes, but you experience them emotionally and viscerally as with ecstasy and a sense of total unity and oneness. And I said, well, that's exactly what the experience was. And so it's rather clear to me as I study this, it wasn't anything new, but was something that was very important to the way we humans were put together.
Many of the great wisdom traditions of the Earth have pointed to what we're calling the overview effect. That is to say, they have realized this unity, this oneness of all life on Earth and of consciousness and awareness.
Within the Western tradition, I think it's quite new and quite shocking, because there's been much more of a sense of separation. But if you look at other non-Western cultures, especially in Asia, the emphasis on those has always been on realization that the self and the world are not separate from each other, but that they're really interconnected, that the individual self and the species as a whole is a manifestation of the larger whole.
As you go into your mind in a contemplative way, the sense of the living reality of the planet becomes obvious. You become more in tune with the natural world.
you look back at it and it's placed perfectly from the sun to take care of us. And you kind of take that reverse role on about, okay, well, we need to be taking care of it too, so that it can continue to do that for us. And I don't know how you can't have a greater appreciation for it after you see it that way.
Next up is speaker Janet Ivey. When thinking about her introduction, where do we even begin with this Renaissance person of STEAM and space? Janet is founder of the TV series Janet's Planet, a show which engages and inspires young minds globally on the exciting world of astronomy, science, and STEAM. She is also president of Explore Mars. Her mission is to inspire and enlighten the hearts of children and encourage them in creativity, self-certainty, inspiration, and a passion for science. Janet has been a part of the STEAMSPACE family since its inception in 2015. We knew the moment we heard her speak to our very first Cities in Space students that she was a gem in the STEAM and the space world and would be taking humanity's youth to stellar heights. And we were definitely right. Please welcome Janet Ivey.
Do you have the right stuff? Then blast off to Janet's Planet Virtual Astronaut Academy. Learn from real astronauts, real pilots, real space experts, and real engineers. Welcome to Janet's Planet, where we're traveling at the speed of thought.
Hello, everyone. I'd like to thank STEAMSPACE, Cities in Space, and my dear friend Holly Malier for the opportunity to speak to all of you. Firstly, let me just tell you thank you for being here, for dreaming of space and bringing your ideas and innovative thoughts to this event. I come to you today from the intersection of art and science. Our art informs our science informs our art, and sometimes the wild imaginings of artists and scientists do indeed become science fact and technological realities. You have prepared and presented ideas about off-world habitation on the moon, near Lagrange point 5, Mars, Phobos, Deimos, Enceladus, asteroids, and maybe even Saturn's moon Titan. And I want you to consider this: what you have imagined, assumed, predicted, and innovated just might be the technology that creates the future. Everyone from science fiction writers to billionaire tech gurus to animated sitcoms have been telling us what tomorrow holds, and their track records have been surprisingly on the money. Here are some predictions that nobody actually expected to come true, and yet That's exactly what happened. Of all the future predictions made in Stanley Kubrick's masterpiece, 2001: A Space Odyssey, there's one that the movie got entirely right. It's not the lunar colonies, at least not yet, but the tablet used by astronauts that looks almost identical to today's iPads. As author Arthur C. Clarke described it in the 1968 novel of the same name, these devices were called newspads and could be plugged into the ship's information circuit to scan the latest reports from Earth. It was a postage stamp-sized rectangle, then it could expand until it neatly filled the screen. When an astronaut had finished, he would just flash back to complete the page and select a new subject for detailed examination. Unfortunately, neither Kubrick nor Clarke lived to see the iPad get released in 2010. In the early 20th century, telephones were still relatively new, but it was audacious for Nikola Tesla to suggest that in 1909, he said that someday that we would be walking around with phones in our pockets. He explained to the New York Times it will soon be possible to transmit wireless messages all over the world so simply that any individual can carry and operate his own apparatus. Now, to be fair, a lot of fiction imagined what it might be like if human beings were capable of flying to the moon. But From Earth to the Moon, an 1865 novel by author Jules Verne, got closer than most with all the details. I mean, it was a little bit silly. A giant cannon fired a manned projectile into space, but he wrote about weightlessness that astronauts experienced. I mean, something an author in the mid-19th century, how would he know that? From Earth to the Moon described 3 Americans' mission to launch a spacecraft and land on the moon. I mean, parts of the novel were similar to the first real moon landing, which occurred 104 years later. Both the Apollo 11 astronauts and Jules Verne characters launched from Florida. NASA's command module was named Columbia, and Verne's fictional spacecraft was named the Columbiad. NASA astronauts Neil Armstrong and Buzz Aldrin succeeded in walking on the lunar surface in 1969, while Michael Collins remained in the spacecraft. The 3 men in Verne's novel, however, never stepped foot on the moon. NASA has acknowledged other similarities between Apollo 11 and Verne's novel. For example, the space agency said the Columbiad's shape and size closely resembled the Apollo spacecraft. The novel also claimed a telescope would be able to see the Columbiad mission's progress. When an explosion caused a malfunction during the Apollo 13 mission in 1970, a telescope at Johnson Space Center was able to see the accident, which took place more than 200,000 miles away. Weird prediction, inspired prophecy, or the power of wild mind to create the future. The iconic communicator device on Star Trek, which was first shown in 1966, looked a lot like a flip phone. Now, the engineers were already developing technology in the 1960s, but it took Motorola until 1973 to debut the first mobile phone. Now, Motorola cell phones would hit the market in 1983, but they were super large and heavy and expensive. But Motorola continued to make improvements for the next several years, and the company's first flip phone was released in 1989, very similar to the Star Trek device. Star Trek featured replicators that could 3D print food and everyday objects in a few seconds. Scientists are now using 3D printing technology to make objects out of plastic, metal, and glass, though the process is not nearly as fast. Startups like Natural Machines are working on making 3D food printers commercially available. One of the most exciting future advances in science is 3D bioprinting. That is the use of modified 3D printers which stack successive layers of material to create objects or cells to construct living tissue. Researchers already have printed skin and vertebral disc and transplanted them into animal bodies successfully, but they're still years and possibly decades away from fashioning a complex organ such as a liver, kidney, or heart for transplant using a patient's own cells as raw material. One day, a transplant surgeon could be able to order a complete organ with certain specs, just as he might pick out a hard drive or all the bells and whistles on a new car. The biggest challenge, researchers say, is not in making the organ itself, but duplicating the complicated internal network of blood vessels that keeps a body part nourished and oxygenated. If you think 3D bioprinting is a weird idea, you'll probably be totally dumbfounded by another, even more innovative concept: the notion of reproducing an object or creating a new one outright by putting it together molecule by molecule. Molecular manufacturing, as it's known, could revolutionize our entire civilization by enabling us to build machines or even buildings quickly and cheaply according to precise specifications and with virtually no defects. The physics principles behind molecular manufacturing are mind-blowingly complex, but in greatly oversimplified words, it basically would involve creating a workforce of scores of tiny little robots called assemblers who would guide chemical reactions and put together a few atoms at a time to create molecules, which in turn would become the building blocks of the object and will actually be able to control the structure of matter. Imagine that. And again, these are all things that people are dreaming about, innovating, and believing will actually work in our near future. The New York-based nonprofit says it has even developed carbon nanotube membranes that could separate and put together individual molecules. Again, whatever you are thinking or dreaming about today might be amazing science tomorrow. Imagine having one of these devices with you on Mars. You could print food, fuels, building materials, and medicines from the atmosphere and soil or recycled parts without having to transport them from Earth. So again, I ask you, weird predictions inspired prophecy, or are they using their own very amazing supercomputer, their brain, to create the future? The Jetsons in 1962 all had a watch that could stream video in color. Now, again, it's very similar to the design we see today. Elroy used his watch to watch the Flintstones and communicate with his family. Now, today's smart watches, such as the Apple Watch, don't have the same video capability, but people use the device to make phone calls, look at photos, and more. And the Jetsons also show very accurately drones and holograms, which, again, are becoming even more ubiquitous. There's not much in Ray Bradbury's 1953 Fahrenheit 451 that we do want to come true. But there's one detail that we're glad became a reality. In the Society of Bradbury's book, they're obsessed with entertainment and need to be constantly distracted by mass media. Many of them do so with little seashells filling their ears with an electronic ocean of sound, of music and talk coming in on the shore of unsleeping minds. Now, who can think of what that might be in the 21st century? You guessed it, earpods. Again, something as simple as that. Someone wrote about it, wrote it as science fiction, and now is coming true, is true. You'll see other things like the walls of Facebook. Isaac Asimov also predicted the rise of autonomous cars by visiting a World's Fair in 1964. And he thought in 50, 60 years, there are going to be self-driving cars and trucks. He said much effort will be put into the designing of vehicles that can be set for particular destinations that will then proceed without interference by the slow reflexes of a human driver. Yep, he wrote that in 1964. Now, autonomous vehicles are already on the road, and many more will be in the coming years. The FAA is even currently designing airports so that you will have a place to park your flying car. I think we've grown accustomed that space travel is something big and expensive and powerful rockets and capable of re-entry and landing. And that costs an awful lot of money. But think about this. Wouldn't it be easier if we could just get on an elevator and ride it slowly but steadily into orbital space, as if we're going for lunch to some very expensive restaurant on the top floor of a skyscraper? Now, such a magical apparatus also would enable us to return to Earth just as easily without having to experience the rigors and risk of rapid re-entry through Earth's atmosphere. Sounds a bit kooky, doesn't it? But scientists predict, and again, these predictions, these wild leaps of fancies have and are creating the future. Many believe that a space elevator will be operational as early as 2070, and definitely by the 22nd century. By 2070, rising sea levels could leave 150 million people fleeing flooded homes. A Belgian architect and design visionary has suggested another alternative. What if instead of fleeing the rising seas, we simply build new cities that float on them? In 2008, he unveiled his design for LilyPad, a 50,000 inhabitant floating city modeled in shape after the giant water lily native to the Amazonian basin. LilyPad would be a totally self-sustaining community with aquatic gardens for growing food, desalination plant to produce drinking water, and energy generation through solar, wind, and wave power. Better yet, LilyPad would be outfitted with a titanium dioxide skin capable of absorbing carbon dioxide from the atmosphere, making just a small dent in global warming. And you all know that Al Gore didn't invent the internet. The first person to dream about the possibilities of a globally connected community might be just as surprising, however. Mark Twain imagined such a future in his 1898 short story from the London Times of 1904, where he introduced readers to something called a telelectroscope that used the phone system to create a worldwide network for sharing information. This innovation, Twain wrote, would make the daily doings of the globe visible to everybody and audibly discussable too, by witnesses separated by any number of leagues. So, the next time you use Twitter and YouTube and Facebook and Instagram, remember that the guy who wrote The Adventures of Huckleberry Finn thought of it first. John Elfreth Watkins was an engineer who was pretty sure he knew where the world was heading, and he shared his thoughts with Ladies' Home Journal in 1900. Many of his predictions never came true, like he thought mosquitoes and houseflies would go extinct. Too bad that didn't. But he got something quite right with startling accuracy, like the advent of digital photography. Photographs will reproduce all of nature's colors, he wrote, and they could be transmitted from any distance. If there be a battle in China 100 years hence, snapshots of its most striking events will be published in the newspapers an hour later. Cameras around the world will be connected electrically with screens at opposite ends of circuits, thousands of miles at a span. The only thing I don't think he saw coming was our tendency to use this amazing technology to take endless selfies and pictures of our breakfast. Isaac Asimov, the legendary science fiction author and biochemistry professor, had a few thoughts also about what the world would look like 50 years in the future. Writing for the New York Times, he told readers that by 2014, gadgetry will continue to relieve mankind of tedious jobs. We can cook auto meals ready to eat within seconds and complete lunches and dinners with the food semi-prepared, stored in the freezer until ready for processing. There would also be devices capable of heating water and converting it to coffee. Well, we may not have any robot butlers yet, but at least we have the microwaves, coffee machines, and Blue Apron and Hello that Asimov promised a half century ago. Now, Heinlein's Stranger in a Strange Land is about alien creatures trying to fit in with human societies. And within that narrative, he creates a typical middle-class home of the future that isn't that far off from what we have today, particularly when it came to personal computers. When a computer or stereo vision tank was left unattended, Heinlein wrote it became disguised as an aquarium filled with animated guppies and tetras swimming around. Or as it's more commonly described half a century later, a screensaver. Thomas J. Watson, founder of IBM, says, there's a market in this world for about 5 computers. What? Between my husband and I and laptops and smartphones and a home computer, we have 5 just in one house. So maybe even great innovators get predictions wrong from time to time. But wouldn't you rather be at least pitching the universe with improbable ideas than binge watching the next thing Netflix suggests? More than 100 years before we learned that Mars had 2 moons, Phobos and Deimos, Jonathan Swift made an educated guess about the red planet. In his 1726 novel, Gulliver's Travels, he wrote about 2 lesser stars or satellites which revolve about Mars. And even more remarkably, he predicted their exact size and speeds of rotation. Given that no technology existed yet that would have made Mars visible, how could Swift possibly have known this? There's been a lot of wild speculation, including theories that Swift himself might have been a Martian. Sounds crazy. So, as you can see, Human after human have been making groundbreaking developments in technology and space exploration for many, many years. Grace Hopper was noted for her curiosity since early childhood, and having been caught by her mother dismantling 7 alarm clocks to see how they worked, she was limited to just one after that. But after the U.S. entry into World War II, Hopper tried to enlist in the Navy, but she was rejected because she was too young and too small. But she persisted and eventually received a waiver to join the Women's Reserve of the Navy. Her perseverance was notable also because of her programming work. And she had this new idea about a programming language based entirely on English. But they said that'll never work because computers don't understand English. It took years before her idea was accepted, but she persisted, and the COBOL, Common Business Orientated Language, has gone on to become the most widely used business language to date. Among many other awards, Hopper was granted the Society of Women Engineers Achievement Award in 1964 and has earned the nickname Amazing Grace. And those were just a few of the folks whose predictions, coming to us in the form of stories, books, art, and real science, either came true and are coming true. It's amazing, isn't it? I believe that imagined future inventions fall into a couple of categories. There are inventions that turn out to be game changers, such as the telephone and the personal computer. But for each of those gadgets that transform civilization, there are probably just as many other technological visions that never actually come to pass. But there's also a third group composed of unexpected discoveries that changed the world, such as British bacteriologist Alexander Fleming's discovery of penicillin, the first antibiotic in the late 1920s. Those, I think, are the ones with the greatest transformational power because they can rapidly, radically affect change that we're not even prepared for. You see, the folks who dare to make bold and outrageous predictions just keep asking really good questions, wondering and dreaming about the answers. And remember this, if you ask enough questions, seek to see out of the box, over the top, crazy ideas, that kind of persistent ideation, no matter how absurd, may lead you to outcomes that never could have been achieved unless you kept relentlessly creating the future. Albert Einstein said, if an idea is not absurd enough, then there is no hope for it. And computer scientist Alan Kay said, you can predict the future by creating it. So here are my predictions for your future. You're going to have your Apollo moment. You'll see the first woman and the next humans return to the moon, set up base, and start training for Mars. You'll see off-world living at the moon, and space tourism will be commonplace. Hey, kids, this year for summer vacation, we're not going to Disneyland. We're going to the moon. You'll see and be the first humans on Mars, researching and figuring out a way to create a lifeboat for humanity. You'll innovate tools for exploration that will cure cancer here on Earth as you farm on Mars. You will solve food scarcity here on Earth. And my hope is you'll create a kind and gentle technology whose algorithms only allow for the truth. You'll create governments and systems that are good, equitable, and inclusive for all and not just for some. You'll find ways to partner across the globe, collaborate for humanity's sake, and find ways to have utter respect and tolerance for those who look, think, and believe differently than you. Now, I could spend time telling you that the SLS just passed another green test run. Perseverance lands on Mars in February, and in a few months, Ingenuity will have its Wright brothers moment on Mars. And this high-risk, high-reward technological experiment will either prove or disprove our hope of flying machines on other planets. But I'm less interested in telling you what is on the horizon than I am about encouraging you to keep reading, pursuing, and coming up with the most outlandish, absurd ideas for the future. And even if you doubt what you are proposing today, thinking that is a crazy idea, keep going and create even wilder and more audacious ideas for the future. Imagine that your kids will not ride the bus to school, but will be hopping in a flying car to make their way to play dates and playgrounds. You will be the ones who innovate great schools, affordable housing, easy access to culture and entertainment on the moon and on Mars. Come to the moon. The best view of Earth is here. But it goes well beyond this. You will create space infrastructures that will propel long-term human exploration to various places in our solar system. You will create communities, cities, and collaborations that will value character, integrity, and conscience above fame, fortune, and greed. You will be the torchbearers of human rights, lunar rights, Martian rights, consistently and equitably, no matter where humans are in space. You see, we are in the midst of the most sweeping transformation of humanity ever. You'll adhere to the Artemis Accords and make the space industry the vehicle for peace for our planet. You'll create the customs, compliance, laws, and justice systems for how we, as humanity, conduct ourselves off-world. You'll see supersonic flight become ubiquitous and use it to lessen the carbon footprint. You'll figure out how best to travel in space, create habitation, grow food, recycle waste, anything that we can think of needing here on Earth. You are now tasked with creating. Oh yeah, you are the architects of all the logistics and mechanisms of our future in space. Just by participating in Cities in Space, you're already creating the ideas that will help us navigate the unfamiliar seas of interstellar space. And please, find yourself a mentor. There are folks that are walking knowledge banks who have been dreaming all these things. And since you may very well be the ones to carry them to fruition, go find your mentor. Ask to learn from them and go forth and make crazy ideas happen. Most of all, I urge you to learn from how provocative words and rhetoric can lead to violence. Choose your words wisely, young people. Life and death reside in the words we use. An ideal of mutual respect, tolerance, and the power of collective action in the name of the global good is what space exploration is all about. Let's go on this journey together to do powerful good wherever in this world that good is needed. So, predict the future by creating it? You bet. When it comes to the future, you have two choices. You can sit back and think, it's not happening to me. No, and build a great big wall to keep out all the bad news. Or you can build windmills and harness the winds of change. We are on the eve of a great transition. In order for the future to occur, someone must first think it, say it, and dream it, and believe it into being. I think a shift of mind is beginning to facilitate the future, and I want to restate the prediction for 2061 that Daniel Quinn writes in The Story of B. The world will not be changed by old minds and new programs. The world will be changed by new minds and no programs. Ooh, what does that even mean? I'm not even sure exactly, but I have enough years on me to be called an old mind. So let your new mind imagine and create the future. I mean, you're already creating the ideas that are going to help us navigate the unfamiliar seas of interstellar space. You and your peers make up the largest generation of young people the world has ever known. And I look forward to the dynamism you all will bring to the space industry. I'm looking forward to you making your mark. And whether it's a city in space or a community on the moon or Mars, this future is yours to write. You will sing this song into the very hearts of stars. You will show us how to turn the dark of night into a guiding light and how to grow jasmine in an audacious place. I have great faith in you. So draw it, write it, build it, dream it, innovate, invent it. Go ahead. Predict the future by creating it. Thank you. Thank you for being here.
Thank you, Janet, for the great work you do every day to support all of our kids across the globe dreaming of space. The world is a brighter place because of the good work you do. And now I'd like to take a moment to recognize our youngest STEAMSPACE and Cities in Space students, our young pioneers. Since our very beginning in 2015, STEAMSPACE has been over the moon to host our youngest future space leaders. Each year at Cities in Space, we have had close to 100 fourth grade students focus on STEAM and STEM in their schools. A huge shout out to Manor, Texas ISD for supporting these young minds year after year. Our young pioneers do not compete in the formal Cities in Space competitions. This is practice for them. Despite not being a part of the formal competition, though, these teams still follow all of the requirements for Cities in Space. They present, they are judged, and they are mentored. Then, they have the opportunity to formally compete in the coming years. Each year, under the direction of some incredible teachers, they get even more comprehensive, more thoughtful, and more skilled at their presentations and their ideas about what is needed to live off-world in a thriving community. I have to say, speaking for our entire team, as well as feedback year after year from our judges, our speakers, our volunteers, that they bring a shining light to our events. We cannot help but smile with great pride for these young teams. So please enjoy this little video taken from previous Cities in Space events highlighting these stellar kids, our young pioneers.
Hello, welcome to Space City.
Which one of you is going to be a space engineer?
I didn't want to.
All of you want to be an engineer?
Hi, I'm the scientist. We're going to be the new generation in Mars.
I believe that humanity's destiny is in the stars.
The favorite thing about it is that we were all working together. This is the windmill, which will transfer the energy to the Wi-Fi tower. We also have thermal energy to make meat out of sugar and yeast. This is the elevator, which is how we get around. It's where you put all your waste and it turns it into clean air. We have a playground and an emergency center. We put a wall between them so kids don't get scared. Try to do things like ideas together to make good things. We are tech like asteroids.
After our probe locates the asteroid, a smaller probe comes out from the bottom to attach its robotic claws.
So we're going to use algae to clean the water if it ever gets dirty.
That is what our thorium reactor.
We'll get it from other planets and then we'll purify it and then we'll divvy it out to everybody. My favorite part about making the colony was painting. My favorite part was the launch pad, especially because of the rocket ship. My brother, he really loves science, so I wanted to tell him about it.
We'll have a colony that can grow and that can move mankind to another place.
Learned that through STEAM we can solve many different problems.
Which of you is going to be the first in space?
Me! I want to!
And now, without further ado, it's time to announce our virtual Cities in Space 2021 winners of our Cities in Space competition. For high school, first place for settlement design from Bangladesh, Team Millennium Falcon.
Venus, the second planet of the solar system and an entity we see each morning in the eastern sky. Within its surface, Venus is a living hell. With a staggering 471 degrees Celsius temperature, it is the hottest planet in the solar system. The pressure at its surface is 90 atm, but the gravity is similar to that of Earth at 8.87 meter per second squared. However, at an altitude of 50 kilometers, the temperature varies from 0 to 50 degrees Celsius and an approximate 1 atm pressure. The dense CO2-based atmosphere above provides protection against cosmic rays and creates a suitable environment for human habitation. Our airship, the Millennium Falcon, is filled with a 21:79 ratio of oxygen and nitrogen that acts as a powerful lifting gas in the dense CO2-based Venusian atmosphere. Our entire airship is divided into 4 individual subs and a central hub. The subs can separate themselves and move individually and later reconnect with the central hub. Energy is mainly produced in 3 particular ways in Venus. Firstly, a solar satellite is launched in space which contains photovoltaic cells. These cells convert solar energy to electricity and transmits it at 2.45 GHz in the form of electromagnetic waves to the receiver station. The receiver station receives this electromagnetic wave and converts it into electricity and stores it for further usage. Secondly, through the use of the Seebeck effect. There is a huge temperature difference between the Venusian surface and 50 kilometers above the surface. This creates a temperature gradient. The Seebeck generator uses this to its advantage and converts the gradient into electric voltage. The higher the gradient, the higher the voltage, and thus higher the amount of energy produced. Thirdly, Wind moves at 12 kilometers per second in the Venusian atmosphere. The wind turbines located outside the airship utilizes this wind energy and produces a huge amount of electricity. The energy from different sources around the Millennium Falcon comes to the electric grid and is stored here for regular usage. Water and oxygen are two essential components for human survival. These are produced in a separate hub through a variety of chemical reactions and natural processes. Oxygen is mainly produced in two particular ways. Firstly, from carbon dioxide. The Venusian atmosphere contains 96% carbon dioxide. This carbon dioxide is stored in a container and later separated through a chemical reaction that produces carbon monoxide and oxygen. Secondly, through the Sabatier process. The Sabatier process uses electrolysis of water to produce hydrogen and oxygen. Water is mainly produced through two particular ways. Firstly, through the Bosch reaction. The Bosch reaction reacts carbon dioxide and hydrogen to produce 2 carbon and 1 molecule of water. Next, the incomplete pyrolysis of methane. Methane is reacted through incomplete pyrolysis to produce ethylene. Then this ethylene is oxidized repeatedly to produce ethanol, and along with ethanol, water is also produced. In these two ways, water is produced along with oxygen. Food, nutrition, and recycling are the basic necessities of human lifestyle. Food is mainly grown aboard the airship by a process known as a vertical hydroponic farming. In this process, plants are grown in water for faster and smoother means of production. Further, different types of bioreactors and hydroponic farming is used in the production of algae. Algae is a type of plant which has multiple purposes, including food and different medicinal purposes. The recycling system within the ship mainly recycles the feces and urines of the inhabitants and converts it into usable fertilizer. Further, different types of bioreactors and hydroponic farming is used in the production of algae. Again, using the ISS recycle system, water is also recycled aboard the Millennium Falcon. The food produced here are transported to the inhabitants' quarters, where the people are supplied with the required amount of food and nutrition. The living quarters and recreation is located in the central hub, of which the top floor is for recreation and the bottom floor is dedicated to the residents. The living quarters has its own bedrooms along with a living room where the people can spend their leisure and improve social interaction along with other psychological benefits. It also has its own gymnasium and also a digital archive for recreational facilities indoor. The digital archive is sort of a digital library which can improve reading facilities and also stores an enormous collection of books. Each residence or living quarter can house 200 inhabitants, and 5 similar airships can house a total of 1,000 people. The second floor is solely dedicated for recreational facilities. A projection-based sports field uses 3D holograms to create its desired sports. Here, basketball is displayed, but this can be converted into volleyball or tennis or any other sport, since all of these are holographic projections. There is an enormous cafeteria beside the projection-based field where the people can come together for all types of snacks and families can dine together, thus increasing the amount of socialization among the peers and also among the members of the family. This enormous cafeteria can house a total of 200 people. Just beside the basketball field is the med bay. The central hub houses the med bay for medical emergencies among its inhabitants. It is a fully facilitated medical system that can run by itself. An AI-based healthcare system is a personalized type of healthcare where An artificial intelligence stores the genetic data and can use it for future purposes. Also, for extreme circumstances, there is robotic surgery, automated robotic surgery, that uses robots and artificial intelligence for surgery. It also has a cryofreezing of 3D bioprinted organs. The Industrialization and Fuel Production Hub mainly collects resources from the Venusian atmosphere and the Venusian surface and uses those to 3D print the required materials. Different components like PVC and other thermoplastics are produced by taking minerals like sulfur and nitrogen from the Venusian atmosphere. Further, ammonia is produced through the Heber process, which is later used to produce hydrogen 50, a hypergolic propellant used as fuel in our airship. This propellant, along with an oxidizer, helps in the movement of our airship and also provides it with the adequate amount of thrust. A flying rover will collect the resources from the heat-resistant rover on the Venusian ground and will bring them back to the original hub, where they will be used to 3D print new and advanced technology for the inhabitants of the Millennium Falcon. And as the flying rover returns to its hub, a floating city in the skies of Venus slowly disappears into the Venusian horizon.
Middle school. First place for settlement design from Brenham, Texas. Team Matrix from Brenham Junior High.
Welcome to the Matrix Apprentice. Here we have the entrance to our ship, and we chose to build our ship in free space.
This is the lobby where you can check in the ship and recreation. So you have meal passes you can get here for the cafeteria. And we have a garden-like feel, or earth-like feel, so it is easier to relax.
This is the medical room where all of your sick patients will be treated. These are the beds, and this is where the medicine is mixed, and also the front desk for the hospital.
This is the cafeteria, where 3 meals a day will be served, obviously being breakfast, lunch, and dinner. That is where you deposit your meal pass to get food. And behind that counter is the kitchen, where food is prepared for being served. And food is then eaten in that room. This is one of our several garden areas with sugarcane, bamboo, and a small pond as well, filled with salmon. Here's our storage area. And here is our other garden with a small farm of wheat and some artificial trees. And here's our actual farm area with a multitude of foods, including wheat, melons, potatoes, carrots, beets, and pumpkins.
This is the school, and this is where the kids in the ship will be learning about the classes. First period will be science, and then their second period will be a free period. The third and fourth period will be ELAR. Fifth period will be lunch and a free period. Sixth period will be flow time. Seventh period will be math, and eighth period will be history.
This is our generator room where that powers the ship's engines.
This will be the school gym. These are the yoga mats, and these are where you lift the weights. And we have a little track area for running.
This is the oxygen room where O2 and carbon dioxide are dispersed to different parts of the ships.
Here we have our art gallery, coming up to our navigation and government room. Here we have navigation, where we communicate and we steer the ship. And we have a little map of our spaceship flying through space. Here we have our government meeting room, where our government decides on legal matters that happen on our spaceship.
This is our escape pods. So when you, in case of a ship malfunctioning or falling, we have a helmet and a wings. So you grab one and you jump out and you'll fly. This is our docking bay where the ships will dock and people can go in. It is able to open and close. So you have to be let in from the inside, just in case.
This is the other weight room that we have. We have treadmills. We have bench presses. We have pull-up bars.
This is our science lab. This is our living quarters where the passengers on our ship will be staying. Each room is fitted with a bed, a flower or two, and a bookshelf. This is a girls' restroom or shower. And over here we have the boys' showers. which are a lot smaller than the girls, as you can see. Here we have the second layer of living quarters, which is basically the same as the last one, just no restrooms. And there is a bit of artwork at the end, which goes into the bar. And then we have our dance floor.
And that concludes your tour of our spaceship. We are the Matrix apparatus, and signing off.
Second place, Middle School for Settlement Design from Pakistan, Team Ninja Brothers.
Hello, we are the Ninja Brothers from Pakistan. Our project is about life on Mars. We have just entered the red planet. This is the rocket ship in which I entered from. But now let's go on and our base camp is already set up, so let's go and give you the tour. This is the solar panel. So when it's daytime, it can generate electricity for our colony. And other than that, here is also the lunar panel, so that when it works the same way, but except it only works when it's night. Now here is the windmill. It works the same way, except when the wind is blowing, it generates electricity. So as you can see, our colony is completely eco-friendly because we do not want Mars ending up the same way as Earth. There could be some disasters on Mars because since Mars is nearer to the asteroid belt than Earth, more meteor showers could happen. So we have installed this satellite so that whenever an asteroid's coming, scientists can know if an asteroid's coming or not. Now, here is the research station. It's got bunch of levers and buttons and stuff. And whenever the satellites capture something, everything it sends back to this research station. These rovers are all over Mars. This little guy loves to explore and send pictures back to the research base. Look, let's get on him. We are going to enter our colony, which we made underground inside one of Mars's lava tubes, because it's one of the lava tubes are one of the safest places we can live, even though it might not sound like it.
And this is our emergency bell, so we can warn the people if there's dangers coming. We are getting water from cloud seeding, and we're getting water from the North Pole of Mars, and we're melting it and filtering it.
Here we have bees which pollinate the plants for us, and we take the fruit from them. The bees also help us get honey, and they're really good for the ecosystem. Over here we grow multiple types of fruits and plants and vegetables for the ecosystem to have oxygen and also to have food.
Hope you guys enjoyed our video. See you on Mars. Goodbye.
First place, Middle School Emerging Technology from Austin, Texas, the Ann Richards School for Young Women Leaders.
STARS STEAM Team, Fashion, Adaptable, Smart Technology.
Hello, our team's name is STARS Team, and our product is called FAST, which stands for Fashionable, Adaptable, Smart Technology.
My name is Alina Zaidi.
My name is Ditya Pai. My name is Gia Latawa.
My name is Sivartika Pandian.
My name is Anika Pandan.
And my name is Anvita Ram. And we go to Ann Richards School for Young Women Leaders, and we're in 8th grade. and we use the engineering method for our project.
This is the problem we focused on our project. So we thought people might have a hard time adapting to the Mars environment because it's very different from the one on Earth. Mars has extreme radiation on its surface and in its atmosphere because of its lack of a magnetosphere, and it also has a very thin atmosphere. Rad is the unit of absorbed radiation dose. An average person can withstand up to 200 rads without permanent damage. Any exposure to Mars radiation can lead to health problems such as acute radiation sickness, increased risk of cancer, genetic damage, and even death.
The purpose. The purpose is to monitor the UV rays on Mars for people in space, to prevent skin cancer and from getting killed by providing alerts on when the UV index is very high, and using the help of a radiation monitor, proximity sensor, and an oximeter. This is to help people adapt and have an easier transition to living in space.
Our research. Some of our research includes that we figured out that the Mars atmosphere is made of 95% carbon dioxide, 3% nitrogen, 1.6% argon, and 1.4% other gases such as oxygen and water vapor. We also discovered that the radiation on Mars is much more than Earth due to the lack of a layered atmosphere. Mars is also home to many craters, mountains, and cliffs, including Olympus Sun, a mountain that is almost as big as a Hawaiian island. And the gravity on Mars is 0.38% the amount of gravity on Earth.
The requirements. The requirements are the prototype should be fashionable, it should be expandable for different health functions, it should be able to attach to different sensors, it should use programmable technology, it should be simple to use, it should use a low power and rechargeable power source, which is environment friendly, and we'll be making the wearable on a spacesuit.
Our idea is that we make a prototype that can attach to a person's clothing. We name it FAST, which stands for Fashionable, Adaptable, Smart Technology. It triggers alerts and buzzes when the UV levels become dangerous, checks your proximity to craters, drops in elevation and volcanoes, measures your temperature and your oxygen level.
These are our testing and results. We tested the prototype by shining an LED light on the UV sensor. When the sensor got too much UV interaction, it buzzed and the light changed from green to red, indicating that our prototype was successful. We also used an oximeter, radiation monitor, and proximity sensor to our prototype.
These are the materials we used for our project. We used a LilyPad ProtoSnap Plus kit with conductive thread and rechargeable battery. We also used an UV ray sensor, a shirt for our wearables, an Arduino IDE for our coding, a multimeter to check our circuits, a pocket finger oximeter, a LilyPad temperature sensor, and a proximity sensor.
Our future features. We added a proximity sensor. Our proximity sensor can detect if there are any craters, mountains, or cliffs nearby. It can also detect and map the topography of an area in case you are near a sudden drop of elevation.
And here I'm holding up the proximity sensor. Our second feature we hope to add in the future is the oximeter. The oximeter is something we use to measure a person's blood oxygen level. It can help monitor if the person is having trouble breathing in space. We will be adding the oximeter in the pocket of the shirt or suit so it's hidden and safe. And here is the oximeter. It's tiny so that we can attach it to our shirt or our spacesuit.
The last new feature that we are going to add is temperature. Temperature is very important to monitor in space. This year, we are going to add a thermometer, which will detect your temperature and help in identifying whether you are safe or not.
This is our LilyPad temperature sensor.
These are our future improvements. We want to add a timer to the chip to see how long we can use it outside, add more health-related sensors, make the device rechargeable with solar panels, make it waterproof, look at cheaper and smaller chips, also try making it wireless and connecting it to an app.
These are pictures of our lily pad and wearable and our UV sensor. This is a demonstration video of our prototype.
As the UV rays get higher, the LED lights increase, and once it reaches a critical level, it turns from green to red and it starts buzzing, as you can see in this video.
During the process of adding our features to our shirt, we learned how to code 3 different things. The first thing was declaring the variables. The second thing was initializing the sensor and buzzer. And the third was creating a loop to measure sensor values.
The woman in STEM that we were inspired by was Arissa Hines. She was an undergraduate at the University of Miami. She was a graduate at MIT, and she did a master's in aerospace and technology. Arissa Hines is a member of the Curiosity Surface Operations team. Currently, she is training to be a rover planner. A rover planner is a team that puts together commands that are going up to the spacecraft. She inspired us because she works at NASA and sends commands to the rover which help collect data.
These are the sources we used for our project.
Thank you for listening.
And second place, Middle School for Emerging Technology, again goes to the Ann Richards School for Young Women Leaders.
Team Felix.
As we continue to explore the limitless possibilities of space, technology will drive the vehicles we use for travel, as well as our sustainability and quality of life.
The axis connects the central hub to a solar furnace, extraction facility, and solar power cells. A habitat radiator comes off of an arm protruding from the central hub. A main mirror is stationed at the top of the axis, collecting sunlight and reflecting it onto the torus, providing UV rays to humans, livestock, and agriculture. The torus spins on the axis of rotation, creating paragravity. The paragravity allows humans to walk on the walls of the hollow torus, creating a livable environment for us to live. Because graphene is lightweight, that allows for the entire space station to spin faster in order to create gravity. This also adds a layer of protection from debris and adds insulation to assist in regulating extreme temperatures. We will be using a rigid heat shield made out of aluminum sheet, which also improves insulation. While there are many heat shields, we've decided on making a rigid heat shield, allowing for a more comfortable and livable space.
Spacecraft Felix is a capsule shape that accommodates up to 144 residents. It consists of 6 branches extending from the central hub, measuring 44 feet in diameter with 3 disc layers, secured by 4 beams and 6 connection bridges to pods. To conserve as much space as possible, the sleeping pods will be narrower, down closer to the core of the space station, and wider towards the exterior walls. To ensure that inhabitants don't feel cluttered, there will be 3 8-hour shifts per day to meet sleep need schedules. We will compost dead plants and human waste for our soil. The gardens will be vertical, meaning each garden bed will be a wall of produce. There will be a system of pipes in the garden beds, giving the plants the exact amount of water they need, hydroponic planters. This is inspired by the Lettuce Grow vertical planters. We will give the plants red and blue LED lights because those are the 2 colors of light plants need the most.
The SS Felix is a step for humankind's expansion in the frontier of space exploration. We must push past the limitations of life on Earth and expand our colony to save humankind from our own destruction.
We have honorable mentions today as well. So many great works we've seen today. I'll remind you again. Honorable mention today for science and engineering goes to Austin, Texas, Hyde Park School.
So our colony is powered by solar panels, and this is like it's sized down for what it is, but it can be easily expanded and with just slight modifications.
You walk through the door, and then you can put your suit on these stands and take your colony clothes.
This is our school, so all the teachers that will come from Earth and all the kids will be able to learn here.
So the farm and park area is there to keep your sanity and keep you exercise and in shapes. And the farm is there to give us a wide variety of vegetarian food so that we can survive on the moon. That's the Hyde Park 2021 Cities in Space presentation. Thanks for watching.
Our honorable mention for sustainability and the environment from Brenham, Texas, Team Withers from Brenham Junior High.
Here we have the farms. We have a semi-automatic farm for crops, and we have a chicken house for eggs, and a cow pen and pig pen for pork chops and beef, and sugar cane for cakes.
And last but definitely not least, our big honorable mention for our young pioneers from Pakistan, Team Pink Fairies.
Hi, we are the Pink Fairies and we're from Pakistan. We made a colony on Mars. Let's go inside. This is our farm. So we grow fruits here and vegetables over here so we can eat them. Now let's go to our library. Here we have huge collections of books for everyone. We have showcased the books in the bookshelves.
This is our beehive. We have thousands of beehives. Bees are very helpful for honey to give us. We have a lot of flowers in here. There's yellow, pink, and red, and blue. This is the animal center. We have cows, and we have sheep and horses. Thank you so much for watching. And Pink Fairy signing off. Goodbye.
Thank you, everyone. Please applaud your fellow peers for their accomplishments, and do not forget to applaud yourself and your team members for a job well done. You reached the stars in our eyes. In the coming weeks, you'll receive your awards and certificates by mail from us. Another special word of thanks to our partners at SLU for their amazing star parties, as well as their free accounts for all of our registered Cities in Space teams. For E360 TV, for the fantastic production and streaming work you have done for Cities in Space and STEAMSPACE. Everyone, please remember that you can re-watch Cities in Space 2021 and share it with your friends from the link at E360 TV. A huge thanks again to our sponsors and supporters, Musk Foundation, Firefly Aerospace, Space for Humanity, Lifeboat Foundation, and Janet's Planet. Thank you. Now you, students, all of you, go create, go collaborate, go build, go lead. You are our future, and we cannot wait to see you next year and how you have grown towards the stars. From the entire team of STEAMSPACE and our board of advisors, our directors, our volunteers and judges, thank you. Till we meet again, keep looking up.